Imagine creating your own AI voices in just a few minutes, right from your browser. In this course, we're going to build a professional text-to-speech AI SaaS app using Next.js 16. This app will sound completely natural and even supports multiple languages, giving you the power to generate expressive voices for any project. To bring this project to life, we'll combine a few powerful tools. For our database, we'll use Neon, a Postgres solution that easily handles scaling and branching. Payments will be handled by Polar, which works in many countries and is simple to integrate. For authentication, we'll use Better Auth, which is completely free and supports email, password, and social media logins. Once everything is ready, we'll deploy our app to Vercel so you can share it with anyone or showcase it in your portfolio for free. All our files and media generated from the text-to-speech model will be stored securely in AWS. To run the AI model efficiently, we will use Modal. This service gives us fast GPU-powered infrastructure for our app to use for free. For styling, we are going to use ShadCN. We will also use Tailwind CSS for utility-based styling. These tools help us build a clean, modern, and responsive interface. In this project, we use Chatterbox as our text-to-speech engine. Chatterbox is an open-source AI model for realistic voice cloning. It can copy real voices with high quality and a natural tone. You can create voices that sound clear, expressive, and easy to understand. Independent benchmarks show it can even outperform popular services like 11 Labs. The model also supports multilingual speech without any extra setup. Users can generate natural voices in 22 languages with one interface. Now let's take a quick look at our project and understand how everything fits together. The homepage begins with a simple and clear hero section at the top. Below the hero section, you will see an area that explains the natural quality of our generated voices. We also include several voice examples to help you experience the expressive sound of our model. For example, here we show a friendly female voice type. You can also see the sample text on the left. Let's listen to this voice sample.
Hi there, I'm excited to help you create amazing voice content today.
Next, we have a voice clone inspired by Stewie Griffin, who is the baby character from the show Family Guy. This example shows how well the model copies his tone. Let's listen to this voice sample.
Introducing the next generation of refreshment. Duff beer just got bolder, smoother, and brewed to perfection.
In the next example, we use a strong protest-style voice. You can see how uppercase letters change the sound. They push the voice to add extra power and feeling. Let's listen to this passionate example.
So I want you to get up now. I want all of you to get up out of your chairs. I want you to go to the window, open it, and stick your head out and yell, "I'm mad as hell!"
We also include a few examples that show multilingual support of the app. For our Indian language example, we have a voice sample in Hindi. Here is the text that was used for this example. Let's listen to the voice.
नमस्कार, हमारे मंच पर आपका स्वागत है.
We also have a Spanish example with this text.
Hola, bienvenido a nuestra plataforma.
Next, we have a French example here. Listen to how natural it sounds.
Bonjour, bienvenue sur notre plateforme.
And finally, here is our Japanese example.
こんにちは。私たちのプラットフォームへようこそ。
Our app actually supports 22 different languages. For the homepage preview, I included only 4 sample voices. You can explore the rest of the languages inside the app. After the voice samples, we have several other sections inside the homepage. We have an information block right here. It features a smooth hover effect for interactivity. Every part of the layout adapts perfectly to any screen size. The entire layout is responsive and visually pleasing. Next up, we have a section that explains how the site functions. Following that is our testimonial section. We conclude with our pricing details and a final call to action. At the bottom, we include a clean and beautiful footer for the website. Let's create a new account for our website and test the full application. Here, you can see the sign-in and sign-up pages, which were generated by Better Auth. Let's sign up with a test email address. After completing the sign-up form, you are redirected straight to the dashboard. Every new user receives 10 credits immediately to test the application. We also include a settings section that lets you update your name, change your email, set a new password, or review your recent sessions. Let's change the name here as a simple example. Your changes are saved immediately. They are written directly to the database. The sidebar is fully responsive and looks good on any screen size. You can use this close button to quickly hide the sidebar. Now let's see how the sidebar appears on mobile devices. It transforms into this compact, user-friendly menu. The menu contains every section of our application. You can easily navigate to any part of the dashboard from here. You can easily see your current credit balance here. Next to it, there is a small drop-down menu for your account. When you open this menu, you can go to your customer portal. There you can review payments and manage your billing details. You can also reach your account settings to update name or email. From this same menu, you can safely sign out of your account. Let's add more credits to our account by making a purchase. Here you can choose between several packs, including 50 credits, 200 credits, or 400 credits. Let's select the small pack that gives 50 credits. You can enter your card number inside this form. You can test the purchase easily by using a supported test card number. You can also select your country from the list. Polar Payment also supports custom discount codes that you can add here. For example, I've created a code named D20 that applies a 20% discount. Let's complete the payment using this discount code. After the payment is processed, you are redirected back to the dashboard. Here you can see that 50 credits have been successfully added to this user. Now let's put our application to the test. Head over to the creation section. This is where you can start generating voices. This is where you type the text you want to convert. You can also select the language for your text here. There are 22 supported languages available for this text-to-speech model. You can upload your own voice samples to clone. Alternatively, you can choose from a selection of pre-made default voices. You can adjust the emotional tone of the generated voice. You have options like making it sound expressive or calm. You can also control the speed to be fast or accurate. These settings help you get the perfect voice output. Let's start by adding some text to our input field. Let's just say hello. My name is Sahand. How are you doing today? Let's make this more expressive by adding emotion. As you can see here, every 50 characters uses up 1 credit. This helps you understand how many credits your longer texts will need. Every 100 characters will also cost 1 credit according to this structure. For example, 100 characters use 1 credit, while 200 characters use 2 credits. Let's go ahead and upload a voice file. We can add the voice named Michael to see how it performs.
We believe that exploring new ideas and sharing knowledge.
Once you upload a voice, it will be added to your personal collection. You can then select it right from this menu. The system will create a clone of the voice sample you provided. This allows the AI to speak using that specific voice. This can be your own voice recording. It can also be any other clear voice you want to clone. The model will use this selected voice to create the final text-to-speech audio. Let's generate the audio using the text we added. The voice generation is completed and ready for playback. Let's click play and listen how the voice sounds.
Hello, my name is Sahand. How are you doing?
The generated voice is also added to the recent generations area for easy access. If you open the dashboard page, you can check your stats. The total audio counter shows 1 new TTS generation from our test. You also see summary numbers for this month and this week. These details help you understand your usage over time. In this section, you can also see your generated audio listed here. You can quickly play it back or download it whenever you need. Inside the projects page, you can view every project you have created. You can also search through the projects using the search bar. You can filter the projects based on the newest order or by their names for easier navigation. You can download any project directly from here using the download button. You can also remove a project from your list by selecting the delete option. You can also see that the credits are now 59 instead of 60. This shows that the last generation used 1 credit from the balance. Let's try another language and see how our voice studio handles it. We can try an Indian text to hear a different style. We can select the pre-built Indian voice from the available options. After that, we can change the language setting to Hindi. We can create a new generation using this setup. At this point, you can see another credit has been used. This means our latest generation was processed successfully. Let's press play and listen to the new voice.
नमस्कार, हमारी मंच पर आपका स्वागत है.
So how does this entire application work behind the scenes? Let me walk you through the full structure step by step. We are using Next.js 16 for the whole project. It gives us client-side routing and powerful server actions. It also supports pages and API routes together very smoothly. All user data is safely stored inside the Neon database. You can see the created user details and their available credits. You can also see that every project created by the user is stored inside the database. For payments, we are using Polar for great flexibility. With Polar, you can easily create discount codes for your app. You can also create different products inside the dashboard. For example, we have large packs, medium packs, and small packs. Polar is a strong alternative to Stripe for global developers. It supports many countries where Stripe is not available. Additionally, we are using Better Auth to handle user authentication. It powers secure sign-in and sign-up flows. It also handles password management with very little setup. The library also supports social logins. Everything is simple to integrate and completely free to use. For deployment, we are going to use Vercel as our hosting platform. It has a generous free plan and gives us a free domain. It also handles automatic builds and fast global delivery for our app. With this free domain, you can easily share your app with others. You can send the link to friends, clients, or potential employers. You can also add it to your portfolio website. This helps you present your project and skills professionally. We also use AWS to store all generated data safely. It is secure, offers a generous free tier, and works worldwide. To run the Chatterbox text-to-speech model, we use Modal. Modal gives us a GPU environment that processes every request. It also saves the generated audio automatically into AWS. Modal gives $30 of free credit each month to use. Each generation usually costs less than 10 cents to run. Shorter clips and simpler settings cost even less. With these free credits, you can run many generations. You can comfortably build, test, and refine your app. I will also share the complete GitHub repository for this course. You will have full access to both backend and frontend code. You can explore every file and follow along with the lessons. You can also reuse the code in your own projects. You can check all the commits to follow each section clearly. You also get full access to the live demo of this project. You can explore it and test all the features. You will see exactly how the app works in real time. To make everything easier, I also created a full project diagram. You can use this diagram to fully understand the system flow. This diagram will also teach you the folder and file structure in Next.js 16. You will see which files or folders control pages and APIs. By the end of this course, you'll have a fully functional, multilingual AI Voice Studio ready to impress anyone and bring your ideas to life. I hope you enjoy working through this powerful project with me. I also hope it gives you clear, step-by-step practice with real skills. These skills can help you launch your own AI SaaS apps. Let's begin our first section by installing Next.js 16. I will see you inside the first lesson of the project. Alright, welcome back to this tutorial session. We are now ready to begin the next part of our project. In this section, we will install Next.js and Tailwind CSS. We will then create our very first project template. I have already built and deployed the final version of the website. You can find it at this address right now. Feel free to visit the live website at this address. You can sign up for an account and test the text-to-speech feature. This helps you get familiar with the application. I've also created a helpful diagram for you. I made this diagram using the eraser.io website. I have shared the link to this diagram for you. You can find it in the resource section of this tutorial. This diagram will help you understand our project structure. You can explore all the files and folders clearly. You will see how to create pages and routes in a Next.js application. This visual guide makes the entire setup process much easier to follow. You can also learn about our database structure. We use Prisma to define our data models. This schema shows you how our application's data is organized. We will use this diagram as our guide to build the project. Let's begin by setting up our project installation. We will use this utility to build our front-end application. We will create a folder named frontend. All our project files will go inside this folder. We will use a helpful tool called the T3 stack. This utility will handle the installation process for us. It sets up all the necessary components automatically. Let me pull up the official T3 stack website for you. You can search for T3 stack on Google. The official website will be the first result. The T3 stack provides an excellent starting point for your project. It sets up a Next.js application with TypeScript already configured. This gives you type safety from the very beginning. We just need to use this command from their website. We can copy and paste it into our terminal. We need to set up our project folder first. Let us create a directory for our application. Let's open up Visual Studio Code on our computer. I will create a new window in Visual Studio Code. I will close the Welcome tab that appears. Next, I will click on the File menu. From there, I will select the option to open a folder. I will create our new project folder in this location. This folder will contain all our project files and code. I am going to name this folder AI Voice Studio App. Let's create this folder now and open it up in our editor. This folder is now our main workspace in Visual Studio Code. It will contain all our project files. Let's open the terminal from the View menu. Let's grab the command from the T3 stack website. Let's go ahead and execute this command directly in our terminal window. I will be using npm to run the installation command. I will copy this installation command from the T3 stack website. Let's head back to Visual Studio Code now. I will paste the command into our terminal here. I want to organize our project structure a bit more. I will create a new folder here. Let's create a new folder for our front-end code. We will name this folder Front-end. This command will start the installation process for us. It will set up all the necessary files and folders. The installation process will present you with a choice. You can select either TypeScript or JavaScript for your project. We are going to use TypeScript for our project. Then we will proceed to use Tailwind CSS for styling. This option sets up a pre-built example website. It resembles a simple blog post application. We are skipping that option for a specific reason. It generates many extra files and folders automatically. This can make the initial project structure feel cluttered. This option creates a complete blog application. You can use that if you want a ready-made project to test. For the authentication option, you should select None. This allows us to build the authentication system from scratch later. I will be creating our authentication from scratch for this project. T3 Stack gives us a choice between two database tools. We can select either Prisma or Drizzle. We will select Prisma to manage our database. The app router is our choice for building the application. This is the modern approach for creating Next.js projects. Our database provider will be PostgreSQL. We are also adding ESLint and Prettier to the project. These tools will handle our code formatting and quality checks. The system is now asking about creating a GitHub repository. We should select the No option at this point. We already have a front-end folder created for our project. Creating a GitHub repository at this moment would be incorrect. It would place the repository solely within the front-end folder. I want to create a single GitHub repository for our entire project. This repository should include both the front-end and the back-end code together. I will select No for the GitHub repository installation at this time. We need a repository for the entire project later. The T3 stack is currently installing an older version of Next.js. I want to use the latest version instead. I will select No for the automatic installation step for now. This allows me to manually update the version number first. We will use import aliases for our project. This feature helps us create much cleaner imports throughout our application. The T3 Stack utility has finished its work. Our application now has a complete file structure. You can now see the generated project structure. We have a Prisma folder containing our schema file. There is also a public folder for static assets. The main source code is inside the src folder. You can view the project structure in the eraser.io diagram. The front end contains various files and folders. The src folder specifically handles all the pages and routes. Inside that app folder, we find several important files. The home page is defined in the page.tsx file in the root of the app folder. We also have folders for authentication and the dashboard. I will explain each of them in more detail later. Let's take a look at the package.json file now. This file contains all of our project's dependencies and scripts. Looking at the package file, we see Next.js version is 15. The most recent version available is actually 16. I will change this to version 16. The latest version at recording time is 16.0.1. After making that version change, we should clear the terminal. Then we can run the npm install command. This will install all the necessary packages for our project. We made a small mistake running npm install in the root directory. Need to navigate into the front-end folder first. The installation command must be run from the correct project location. We need to move into the front-end directory first. This is where our installation will take place. Now you can run the npm install command. This process will download all required project dependencies. This command will install all the packages listed in our package.json file. It includes Next.js, React, and all the other necessary dependencies. The installation process is now finished. We can see all the necessary packages have been successfully installed. Let's run the application to see if everything is working correctly. We can type npm rundev to start the development server. You can confirm the version number is 16 in the terminal. Our development server has started successfully. It is now running locally on port 3000. You can access it through your web browser. Let's click on this link now. This will automatically open our application. It will appear in your default web browser. The T3 Stack utility has generated our initial project template. Let's go ahead and delete this default template content. Let's move our browser window over to the right. We will position our Visual Studio Code window on the left side. Let's navigate to the homepage file for our application. You can find it inside the app directory as page.tsx. Let's clear out all the default content from this file. We are starting with a completely blank page. We will create a React functional component. We can use the RFC snippet for this purpose. Let's name this component homepage. Let's test if Tailwind CSS is working properly. We can add a class to change the text color. For example, we can make the text appear red. You can see the text is now red. This confirms Tailwind CSS is working correctly. Let me show you the Visual Studio Code extensions I use. These tools help make my development workflow much smoother. The Auto Rename Tag extension is a very helpful tool. It automatically updates both the opening and closing tags for you. This saves you from manually changing each tag individually. The next extension provides snippets for React and Redux. These snippets help you write code faster. For example, I used one to create the React functional component. I have also installed GitHub Copilot for my own use. This tool acts as a helpful assistant during the coding process. I would suggest using these tools for your own projects. They are incredibly helpful for development work. Using these extensions is completely optional for our tutorial. You can follow along successfully without installing them. The Multiple Cursor Case Preserve extension maintains your text casing. Prettier automatically formats your code for consistency. The Prisma extension helps format your Prisma schema files. We also have Python extensions for our backend work later. You can pause the video right now. Find these extensions in the search bar and install them. Another very useful one is Tailwind CSS IntelliSense. This extension will suggest Tailwind CSS classes for you. That covers the extensions we'll be using for Visual Studio Code. Now that our extensions are set up, let's create a GitHub repository for this project. Let me stop the development server now. I will also clear this terminal window. Let's navigate back to the root directory of our project. Let us create a separate backend folder now. This will help us confirm our project structure is set up correctly. Next, I will create a folder named backend. Inside this new backend folder, I will create a test file. This file will serve as a placeholder for now. I want to include this file for a specific reason. It ensures both folders appear in the GitHub repository after the upload. This confirms our project structure is correctly saved. We are now positioned in the main project folder. Let's initialize a new GitHub repository from this location. We can do that with the command git init. This command will initialize a new Git repository for our project. It sets up all the necessary version control files. Let's clear this terminal window to keep our workspace clean. Our GitHub repository has been successfully initialized. We are now ready to start tracking our project changes. Let's proceed to add everything we have created to our GitHub repository. This will include all our current files and folders. Before we proceed any further, I noticed something in the frontend directory. The installation process created an extra folder named generated. Let's go ahead and delete that folder for now. We will generate the Prisma client a bit later. This step comes after we have added the database to our project. We will go ahead and delete this folder for now. We can generate it again later when we add the authentication. We will now add all of our project files to the repository. This prepares everything for the next step. We will create a commit with a descriptive message, install Next.js and Tailwind CSS, and create the first template. Let's commit these changes locally first. After that, we should create the actual repository on GitHub. Let's open our web browser and navigate to the official GitHub website. Make sure you have already signed into your GitHub account. The best part is that using GitHub is completely free. You can create as many repositories as you want without any cost. Look for the plus icon at the top right. Click on it to open the menu, then select the option for a new repository. Let's head over to GitHub now to create our new repository. We will set up a fresh repository for this entire project. I will name this repository AI Voice Studio App. Let me also write a brief description for the project. AI Voice Studio SaaS app using Next.js, Tailwind CSS, Neon, Polar, and Modal. I am making this repository public for everyone to access. You can absolutely set yours to private if you prefer. I am keeping this repository public for you. You can easily access the code here. This way, you can get a copy for yourself. The next step is to copy these 3 lines of code. Then you will head back to Visual Studio Code. Inside the terminal, paste the 3 lines you just copied. This command will upload our entire codebase to the GitHub repository. You can now refresh your GitHub repository page. Both the front-end and back-end folders are visible there. If you run into any coding problems, you can visit the GitHub repository. Go to the commit history section. You will see all the changes I've made. This allows you to compare your code with mine. You can also copy and paste sections if you find that easier. I will also add the link to the final deployed website. You can visit it directly from this repository page. That concludes the installation of Next.js and Tailwind CSS using the T3 stack. Up next, we will tackle the authentication system. This is a crucial part of our project. We will set up user login and sign-up features. I look forward to seeing you in our next session. We will begin working on the authentication system. We are now beginning the authentication portion of our project. This is a crucial step for securing user access. For handling user authentication in our project, we will use Better Auth. Let's open up Google in our browser. We will search for the Better Auth website. Let's click on the very first search result. This should be the official documentation page for Better Auth. Here we are on the official Better Auth website. This is the main hub for their documentation. Better Auth stands out as the most complete authentication framework available. It is specifically designed for TypeScript developers. This framework provides everything you need for user management. What truly sets Better Auth apart is that it's completely free. It also includes every authentication method you might need. Creating authentication with this provider involves a bit more initial setup work. You will need to configure several components manually, but you get access to all these powerful features completely free. First, let's open the documentation. We need to find the installation section to get started. Now we can install the Better Auth package. We will use this specific command from the documentation. I am going to copy this command now. We will head back to Visual Studio Code. I have already opened a new terminal inside the application. I am installing this package inside the frontend folder of our project. We paste the copied command into the terminal. Then we press the Enter key to start the installation process. The package has been successfully installed in our project. We can now proceed with the next steps. Our next task is to set up the environment variables. This step is clearly outlined in the documentation. Next, we need to add two important environment variables. We will add the Better Auth secret key. We also need to add the Better Auth URL. We click the Generate Secret button to create our secret key. We then copy this entire generated value. We paste it directly into our environment file. I will also add these variables to our example environment file. This example file will be uploaded to the GitHub repository. However, the actual environment file will be ignored by Git. This way you can see the required structure without exposing any secrets. I will add the example variables to this file for your reference. I will change the actual secret key to a placeholder value. This ensures the real key stays secure when we upload to GitHub. Let's navigate back to the Better Auth documentation page. We need to locate and copy the Better Auth URL as well. I will now paste this Better Auth URL into our environment file. We have added our environment variables to the project. The next step involves defining their types. We will add these types inside our env.js file. We need to define the Better Auth secret next. This variable must be a string. We also define the Better Auth URL. This will be a string formatted as a URL. Now we need to head over to the runtime environment. We have to add these new environment variables there as well. We set the Better Auth secret variable using process.env.betterAuthSecret. We also define the Better Auth URL variable here. This type safety ensures our environment variables are properly secured. You cannot accidentally use a number in place of a required string. This prevents common coding errors right from the start. Our next task is to create a Better Auth instance. You can find this step in the documentation. This instance will handle our authentication logic. Our next step is to create a configuration file for Better Auth. We will name this new file auth.ts. This file should be placed inside a new folder. We will call this new folder lib. Now, if you take a look at our project diagram on Eraser, you can see I have already created a folder inside the src directory. This folder is named lib. Inside this lib folder, we have our auth.ts file. Let's proceed with creating this structure in our own project. Let's navigate back to Visual Studio Code. We will go into the src folder. Then we create a new folder named lib. Now we will create a new file inside this lib folder. We are going to name this file auth.ts. Let's navigate back to the Better Auth documentation. You will find a dedicated tab for Prisma integration. We can copy the provided code directly from that section. Then we will paste it into our project's new authentication file. We must update our database provider to PostgreSQL. We also need to import the Prisma client. This import statement must come from the correct location in our project. Our next step involves updating the Prisma schema. This process is very straightforward with Better Auth. They provide a special utility to handle this for us. Better Auth provides a convenient utility for this. You can use their built-in tool. It makes updating the schema very straightforward. We can simply copy this command from the documentation. After that, we will paste it directly into our terminal. We are going to press the Y key on the keyboard. This will allow the process to continue. It looks like we're getting an error message. The error says the Prisma client did not initialize yet. The error is telling us to run the Prisma generate command first. Let's generate our Prisma client first to resolve this initialization error. We need to remove this local output configuration. Our goal is to upload the schema directly to our remote database. We are using Neon for our database hosting. With that output path now removed, Let's run the database generate command. It looks like our database connection is pointing to localhost port 5432. That is not the correct configuration we need. We need to check the package.json file for that issue. Let us examine the database configuration there. Let's run the Prisma generate command at this point. This will generate our database client. Before we continue with our setup, let's visit the Neon website. We need to retrieve our unique database URL. Head over to the official Neon website. You can use the link in the resource section. Neon is a serverless PostgreSQL database built for modern web apps. It scales automatically, making it perfect for Next.js on Vercel. This ensures fast and reliable connections for smooth performance. You can branch your database instantly to test new features safely. It works seamlessly with Prisma and Drizzle for simple integration. Together, these features let developers focus on building great apps. The best part is that Neon offers a generous free tier. You can start using it without any cost. The free plan allows you to create up to 10 different projects. Let us create a new project for our application. For the project name, I will use AI Voice Studio App. Let's create our new project now. We can click the connect button. This will give us a connection string. We need to copy this code. Then we paste it into our environment variables file. Let's attempt to generate our database schema once more. We should now have the correct connection string configured. Our next step involves naming this new migration. We need to provide a descriptive name for this database update. Let's call this initial migration first for now. Let's navigate back to the Neon website. We can now check the tables section. Let's take a look at our database tables in Neon. We can see the post table that was automatically created for us. Let's run the Better Auth utility to update our schema. This will add the necessary authentication tables to our application. Now let's run the Better Auth utility command inside our front-end directory. This will properly set up the authentication tables in our database. I will return to the documentation page. I need to copy that installation command once more. The utility command we tried seems to be having some trouble. Let's see if we can find an alternative approach. The previous utility command did not work as expected. It looks like we should try a different command from the documentation. Let's copy this alternative command instead. The system is now prompting me with a question. It is asking if I want to override the existing database schema. After confirming with a yes, we can now check our updated schema. We should see that the user model has been successfully added. The session model is also present in the schema. Additionally, the account model has been included as well. We can remove this post model from our schema. It is not necessary for our current project. I am going to add a credit field to the user model. We want to give new users 10 credits when they register. This credit field will be an integer type. It will have a default value of 10 credits. We need to add 2 more features for our users. These are audio projects and uploaded voices. Now we need to create 2 new models in our database. These models will be for audio projects and uploaded voices. We will create the audio projects model first in this section. This model will store all the generated audio files for our users. It will include an ID field for unique identification. We also need a name field for the project title. Next, we add a text field for the script content. All these fields must be of the string type. The next step involves adding the remaining attributes to complete this model. We need an audio URL stored as a string. This S3 key will hold the file's location in AWS S3. We also need to specify which language the audio is in. This is important for accurate speech synthesis. We also need to store the voice S3 key. We will track the amount of exaggeration for the voice. We must include the weight of the voice. Finally, we link this project to a user ID. We will also record the creation and update timestamps. This completes our model for the audio project. The uploaded voice model contains several essential fields. It has a unique identifier and a name. There is also a storage key and a URL. Each voice is linked to a specific user. It records the creation time and the last update. Our Prisma schema is now fully configured. Let us generate the client once more. This will update it with all our recent changes. Now we should give a descriptive name to our new migration. Let's call this one completed. The database schema has been successfully updated and synchronized. All our new tables are now properly reflected in the database. Let's go back to the Neon website and refresh the page. We should now see our updated database tables. Our database now contains all the required tables. We have accounts, audio projects, and sessions. We also have uploaded voices, users, and verifications. Our database schema now perfectly matches the design we planned in Eraser. Our database now includes the verification and session accounts. We also have the audio project table set up. Additionally, the uploaded voice model is now in place. Each database model has a direct relationship with the user. This means each user can manage multiple audio projects. They can also upload and use their own custom voices. Now we need to configure an authentication method. We can find this step in the Better Auth documentation. For authentication in this project, we will use email and password. This method is straightforward and secure for our users. I will now copy this authentication code. Let's go back to Visual Studio Code. We need to paste it inside our auth.ts file. Now we need to set up the mount handler. This allows our authentication system to handle incoming API requests properly. Since we are using Next.js for this project, let's select the Next.js tab in the documentation. Next, we must create a file named route.ts. This file should be placed inside our application's API directory. Let's look at the project structure in our diagram. We need to create a new API folder inside the app directory. Inside that API folder, create another folder named auth. Within the auth folder, make a new folder called all. Inside the all folder, we will create our main root file. Let's create these folders and files inside our Visual Studio Code editor. Now we need to create a new directory for our API routes. We will make this folder inside the main app directory. Let's call this new folder API. We need to create these folders and files. Let's follow the structure we saw in the diagram. Let us create these folders and files right here. Next, we can copy the code directly from the Better Auth documentation. We will paste that code into our new file. Finally, we need to handle the auto-importing of any necessary modules again. Excellent, our setup is now functioning properly. The next required action is to create a client instance for our frontend. We will create a new file for this. This file will be placed inside the lib folder we created earlier. Let us create that file in the lib folder now. We can go back to the documentation. We will copy the provided code from there. Then we will paste it directly into our new file. You need to update the base URL. Make sure it matches the URL you have set inside your environment variable file. We have now completed the installation process for Better Auth. We have reached the final stage of the installation process. The setup is now fully complete and ready to use. Our next step involves creating the authentication pages. We need to build a sign-in page and a sign-up page. We also need to create other related pages for the user flow. Let me introduce you to a fantastic package called Better Auth UI. This package handles all the authentication pages for you. To find this package, we can open a web browser. Let's search Google for Better Auth UI. Here is the official website for Better Auth UI. Let's click on this link to visit the official website. Better Auth UI is built on top of the ShadCN library. It will automatically generate all of our authentication pages for us. Before we can use Better Auth UI, we must first check its requirements. We need to install two specific packages. These packages are ShadCN UI and Sonar. Let's click on this link to visit the ShadCN website. We need to navigate to the Getting Started page. We can see the Next.js installation guide. This page provides a command we can use. We will install the package using this utility. Let's go ahead and copy this installation command. Let's head back to Visual Studio Code. We need to clear the terminal first. Then we can paste the code we just copied. Let us copy the npm install command. I will use npm for this installation. I will paste the npm install command into the terminal. I will press the Y key to accept this installation. Let's select the base color option for Shad CN. We will choose the neutral color scheme for our project. Excellent. The Shad CN component library has been installed successfully. Let us return to the requirements section for the next step. The next requirement is to install a package called Sonar. Let's copy this installation command for Sonar. We will head back to Visual Studio Code. We can clear the terminal and paste the new command there. Now that we have Sonar installed, we need to add it into our main layout file. Let's copy this code snippet. We will return to Visual Studio Code. We need to open our layout file. We will paste this code right after the children section. We also need to import the necessary component. This import comes from the component's UI Sonar directory. Let's return to the Browser tab with the documentation. Let us proceed to the Installation tab. We can now install the Better Auth UI package. The installation process for Better Auth UI is now finished. We can proceed to the next configuration step. Let's go back to the Better Auth UI website. We already have installed Tailwind CSS version 4. Our next step involves the global CSS file. We must add this specific code snippet there. Let's copy that code snippet. We return to our styles directory. We navigate to the global.css file. We will add this code to the very top of the file. The next step in the process is right here. We will proceed with this instruction now. Our next step involves creating a providers file. We need to make a new file named providers.tsx. Let's copy this entire block of code from the documentation. Let's return to Visual Studio Code. We will navigate to our components folder. Inside that folder, we will create a new file. We can call this file providers.tsx. Let's copy this entire code block. We will paste it directly into our new providers file. Let's take care of this import issue. We need to fix the import statement first. Let me delete this incorrect line. I will import the component properly instead. We have created the providers file. Now we need to add this provider to our layout file. Instead of adding it to the main layout file, we will place it within the auth folder. Looking at our project structure in the app directory, you can see the dashboard and authentication pages are in separate sections. We need to create a folder named auth. This folder name uses parentheses. Next.js will automatically ignore this special folder. Inside this new folder, we will create another folder named auth. Then, within that auth folder, we will create a path folder. Inside the path folder, we will place our page file. The layout file will be placed in the root of this folder. Let's head back to Visual Studio Code now. We need to work inside the app directory. Let's create a new folder inside the app directory. We will name this folder auth and include parentheses around the name. Inside this new folder, we will create another folder specifically named auth. Inside this auth folder, we will create a layout file. This layout file will be placed at the root of that directory. Looking at the final version of our application, we can see the sign-in page layout. There is a visually appealing section on the left. The main sign-in or sign-up component sits on the right. This layout code has been placed inside the layout file. This layout is a static web page. It does not contain any interactive functionality itself. It simply provides the visual structure for the authentication forms. I will copy the layout code directly from our repository. This saves us time from writing everything manually. The complete code for this layout is available. You can find it in the project's GitHub repository. Let's navigate back to our project workspace. We need to open the layout.tsx file. I will paste the code into this layout file now. We are going to wrap everything with the provider component we created. This ensures the entire section has the necessary context. This is the provider file we just created. It wraps our authentication pages with the necessary context. The left side contains purely aesthetic elements. These elements include the logo and similar items. The right side displays our authentication form. This form dynamically includes all components. These components come from our designated authentication folder. Let's go ahead and create those files in our auth folder now. We need to set up the page files for our authentication forms. Let us navigate back to the Better Auth UI documentation page. We need to create our authentication pages next. Our next step involves creating a page file. This file will be named page.tsx. We will place it inside the auth folder. Specifically, it goes into the path folder within that directory. Let me copy this code snippet for our page. Inside this folder, I will create a new folder named auth. Then inside that, I will create a folder called path in brackets. Finally, we will add our page.tsx file there. We want to copy and paste this code next. This single action will generate all our essential authentication pages for us. It automatically creates the sign in, sign up, and forgot password forms. Let's add a new attribute here called redirect to. This will automatically send users to the dashboard after they sign in. Let us navigate back to our website in the browser. We will go to the sign in page at the address auth/signin. We are encountering an error at this point. We encountered an error because we tried to access a server-side environment variable from a client component. To fix this error, we need to return to Visual Studio Code. We must navigate to the auth-client.ts file. The import statement there should use the correct environment variable prefix. We can now see our sign-in page loading correctly. The interface appears exactly as intended. We can navigate to the sign-up page and the forgot password page. All these authentication features are functioning correctly. Let's navigate back to the home page now. Let's test the sign-up process by creating a new user account. We will fill out the registration form with some sample details. Let's enter a test email address for our new user. We can use something simple like sahan3@gmail.com. Let's use the same password we just entered. This will help us confirm everything is working correctly. Let's go ahead and create this new account for our user. We have been successfully redirected. We are now on the dashboard page. Let's check our Neon database users table. We can confirm the new user was successfully added. Let's navigate back to the sign-in page. We should test the login functionality with our credentials. Let's use the same email address we just registered with. We will also enter the matching password. Then we can proceed to log into the account. You can see that the login process is working perfectly. The authentication is functioning exactly as expected. Let us verify the session cookie was created successfully. We should open the browser's Developer Tools panel. Navigate to the Application tab within that panel. Then look under the Cookies section for our local host site. You will find the Better Auth session token listed there. Our authentication setup using Better Auth is now complete and fully functional. We have successfully implemented secure user sign-up and login processes. Let's commit our authentication setup to the GitHub repository. We should push all the changes we have made. I'm going to select all the changes we have made. Let us check what the git status command suggests for us. Let us use this commit message. Now we can commit and push these changes to the repository. We have successfully completed our authentication system. Next, we will begin developing the project dashboard. Welcome to this section where we will focus on the dashboard page. Our main task is building the sidebar component for the interface. Take a look at the finished application in this view. You will notice a sidebar positioned on the left side. This sidebar contains the main navigation menu for the application. At the very top, you will find our application logo. Next, you will see the user's current credit balance displayed. A button is available for upgrading the account. The account information section is located here. It includes a menu with several options. You can access the customer portal from this menu. You can also navigate to your settings. Finally, you can sign out of the application. This sidebar component is designed to be fully responsive. It automatically adjusts to work perfectly on all devices. Let me shrink the screen down to mobile size. You can see we have this mobile menu appear. Let me quickly refresh the page for you first. This menu can be opened and closed. You can control it using this button right here. This is the correct mobile layout in action. You can see how the sidebar adapts perfectly. The mobile sidebar opens fully when you need it. You can view all the menu items on a smaller screen. At the top of the page, you will notice a breadcrumb navigation. This breadcrumb clearly indicates which menu item you currently have selected. You can see the breadcrumb update at the top of the page. It now displays the word Create after I click on that menu item. For building our sidebar, we will use a pre-built component from ChatCN. This component is specifically named Sidebar. This component gives us all the essential features we need. We can build a very polished sidebar for our application. We just need to install the sidebar component. Looking at the project structure in the eraser diagram reveals an important step. We must create a dedicated folder specifically for the dashboard. All dashboard-related components and files will reside within this separate folder. This organizational structure keeps the dashboard completely separate from the authentication pages. This dashboard will have its own layout file. This layout will contain all the shared components for the dashboard section. Looking at the finished application, you can see the dashboard layout. It contains the sidebar and the breadcrumb component. All the elements you see on this page are included. Every single page in the dashboard uses these exact same components. Let's start by creating our dashboard page. Let me open the correct coding environment for our project. Let us navigate to the front-end directory. Then we will open the source components folder. You can see we have not yet installed the sidebar component. Let us begin by creating our dashboard page. We are going to create a new folder inside the app directory. This folder will be named Dashboard with parentheses. Now we need to create another folder inside this one. We will name this new folder Dashboard as well. Inside the Dashboard folder, we will create our main page file. This file will be named page.tsx. We will create this file first. We are going to call it the dashboard page. Next, we need to create a layout file for the dashboard. This file will be named layout.tsx. Let's return to our website to see the current status. You can see an error message on our website now. We need to complete the layout file to resolve this issue. Let us begin by creating a simple layout to get started. I am going to create a straightforward layout for this section. This layout will receive the children components and display them all. It will primarily render the content from our page file. Let us check our website now. You can see we have the dashboard page ready. It is accessible at the /dashboard root. Next, we will navigate back to the ChatCN UI documentation. We need to install the sidebar component first. Let's copy this npm install command from the documentation. We will head back to Visual Studio Code. I will paste this command into the terminal. Make sure you are inside the front-end folder. This command will install several useful components for our project. We will get a separator, a sheet, and a sidebar. It also includes a skeleton and a tooltip. We have a few more important tasks to complete in our layout file. Let us address these items at the very top of the layout component. Next, we need to import the global CSS file into our layout. This step ensures all the necessary styling rules are properly applied. We also need to import our providers component. This is an important step for the application. Earlier in our project, we built a special component called providers. This component handles all the authentication logic for our application. This provider wraps our entire application. It ensures the authentication system works everywhere. The dashboard section now has full access to authentication features. We also need to import the Toast component from the Sonar library. This will allow us to display Toast notifications within our dashboard application. We need to integrate this Toast notification component into our application. This ensures that any Toast notifications will also appear on your dashboard. Next, we must import several items from the sidebar component. These include the sidebar inset, the sidebar provider, and the sidebar trigger. We will update our code carefully to match the example. This ensures our layout works correctly with the sidebar. We need to wrap our entire application with the sidebar provider. This ensures the sidebar works correctly across all components. Now, if we examine the final application, you will notice a dividing line right here. Let me zoom in on this section for you. This will make the separator line much easier to see. You can see that vertical line right here. This is the separator component. We already have the separator component installed in our project. This component is ready for us to use. We need to import the separator component next. The breadcrumb component will display our current page in the dashboard header. It shows which section you are actively working on. In the final version, you can see we are on the settings page. The breadcrumb correctly displays the word settings. If we navigate to the projects page, it will show projects instead. Let's install this component in our Visual Studio Code terminal. Let me clear out the terminal window first. Then I will paste the installation command. Let's copy this installation command and paste it into our terminal. This will install the breadcrumb component we need. Let's add some metadata to the layout file. This metadata will define the page title and description. We will set the title to AI Voice Studio. The description is also defined here. The icon is specified in this section as well. We place all the page content inside a main section. The remaining elements will be positioned within a header area. Above the main content area, we add a header section. This header contains 3 important elements. First, we have the sidebar trigger button. Then we add a visual separator line. Finally, we include our dynamic breadcrumb component. For instance, if you type the word settings, you should immediately see settings appear on our website. You can see the word settings displayed clearly right here. We currently have 2 sidebar triggers visible in our layout. Let's remove one of those extra triggers right here. Now you can see we have just a single trigger remaining. We cannot simply hard-code the word settings here. We must fetch the current URL first. Then we can display the correct page name based on that URL. Let's return to our Visual Studio Code editor. We need to continue building our breadcrumb component there. Let's create a new file in this location for our breadcrumb component. Let's create a new folder named Sidebar inside the Components directory. Then we will create another folder inside it called Breadcrumb Page Client. Let's build a React functional component for our breadcrumb. This component will handle the navigation display. Let us add this new breadcrumb component to our dashboard layout. This will replace the hard-coded settings text we currently have. Looking at our current website application shows this breadcrumb. We want this display to change dynamically. The content should update based on the current page URL. Let us now focus our efforts on building this specific component. This component needs to run on the client side. It requires user interaction to function properly. We need to mark this as a client component. We add the useClient directive at the top of the file. First, we need to import a hook called usePathName from Next Navigation. This will allow us to get the current URL path. We also need to import the breadcrumb page from the breadcrumb. We will use the usePathName function to get the current URL path. Based on this path, we will dynamically display a different breadcrumb. For instance, when the URL path is exactly /dashboard, we want the breadcrumb to display the word dashboard. We need to handle different URL paths in our breadcrumb. For the dashboard/create path, we want it to display create. The breadcrumb component will show the correct title based on the current page path. Let's open our website to see the result. You can see the dashboard breadcrumb is now visible. This appears because we are currently on the dashboard page. Our breadcrumb component is functioning exactly as expected. Now we are ready to finish building our sidebar component. Our next step involves creating a separate component for the sidebar. We will name this component app Sidebar. Then we will integrate it into our dashboard layout right here. Now let us navigate back to our Visual Studio Code editor. We need to work inside the sidebar folder we created earlier. Let's create a new file named appsidebar.tsx. This file will contain our React functional component. We are going to name this component app sidebar. Our next step involves adding this sidebar component to the dashboard's layout file. Let's add the sidebar component at the very top of this layout. Place it right after the opening tag for the sidebar provider. We should import that component into our layout file as well. Let's check our website now. We should be able to see the app sidebar component in action. Our app sidebar component is designed as a server-side component. This means it will be rendered on the server first. This component will be a server-side component. We will use the server directive for this. This component will be rendered on the server first. The main page content will then be rendered afterward. First, we need to import the user button component from Better Auth. Let me demonstrate the final version's user button component. You can also find this user button in the Better UI documentation. It displays a convenient menu and shows the user's information. We need several icons for this user button. We require a sparkle icon and a user icon. We also need icons for settings and sign out. We also need to import the link component from Next.js. This allows us to navigate between different pages in our application. We begin by wrapping our application components. We will use the sidebar, sidebar content, and sidebar group elements. This structure is essential for our layout. Let's begin by adding our logo to the sidebar. This is the first element users will see at the top. Let's go ahead and add this logo section to our sidebar now. We add a sidebar group label component. Inside this label, we place a link element. This link redirects the user to the home page. It also contains a sparkles icon. Then we display the words AI Voice Studio. When you click on this logo, you will be redirected to the home page. Let us now review the changes in our web application. Let's check our website and see what this app sidebar error is. The error message indicates that server actions must be asynchronous functions. This means we need to change the function to be asynchronous. We need to change this function from synchronous to asynchronous. This will resolve the server actions error we encountered. The installation is now successful. We have no errors showing up. You can now see our application logo displayed in the interface. Clicking the logo will take us back to the home page. Next, we will add the sidebar footer component. This footer will display the user button from Better Auth. This button shows important account information and menu links. Next, we will add a sidebar footer section. This footer will contain the user button from Better Auth. We will place this at the bottom of our app sidebar component. This user button from Better Auth comes with several configurable properties. We can customize its behavior and appearance using these different attributes. One important feature is the additional menu links. These links provide extra navigation options for the user. We want to include a link that directs the user to the customer portal. This portal is located at the dashboard/customer portal address. We also need another link that takes the user to the settings page. If you look at our website now, you can see the footer. It displays the user's information like their name and email. You will also find 3 links there for customer portal and settings. The sign-out functionality is already built into the links. It appears automatically within the user menu. Now we need to build the main navigation menu. Our menu contains 4 main navigation items. These items are Dashboard, Create, Projects, and Settings. Let's create a separate component specifically for our sidebar menu. Let's navigate back to the sidebar folder. We will create a new file for our menu component. Next, we will create our React functional component. This component will serve as our menu navigation. Let's name this function Sidebar Menu Items. This will be a client-side component. We need to import the necessary icons from the Lucide React library. We also need to import the usePathName hook from Next.js navigation. We will use this hook to activate the correct menu item. We need to highlight the currently selected menu item. This will show users which section they are viewing. We also need to import several elements from the sidebar components. These imports come from the ChadCN sidebar component. We also need to import the link component from Next.js. This will allow us to navigate between different pages in our application. We need to import CN from our utility functions. This helps us combine Tailwind CSS class names together. We will now get the current page path using the usePathName hook. We also create a hook to handle mobile devices. We use the useSidebar component from ChadCN. This hook will let us check the current screen size. We can use it to determine if we are on a mobile device. We'll start by defining an array of menu items. These items will represent the different navigation options for our sidebar. We are going to define an array for our menu items here. Our menu includes several navigation items. We have options for Dashboard, Create, Projects, and Settings. Each item has a specific destination URL. We also assign a unique icon to every menu item. Right now, none of these menu items are set to be active. We will determine which menu item should be active. This decision is based on the current URL path of the page. We will map through all the menu items. For each item, we check if its URL matches the current path. If the URL matches, we set that specific item to be active. Let's refine this section by focusing on the return statement. We need to properly return our menu items. We will now return all of the menu items we have defined. This will display each item in our sidebar navigation. We are going to begin by using the sidebar menu item component. We will iterate through each menu item in our list. Then we will display each one using the sidebar menu item component. Each menu item is essentially a button element. We will use each button as a child component within our sidebar. The component is a button element. Placing it inside another button would create a nested button error. This structure correctly avoids that problem. We will activate the menu item only when its active property is set to true. The item's appearance will also change based on its active status. We want each menu item to navigate to its corresponding page when clicked. We also want the mobile menu to close automatically. This happens when you tap on any menu item. Let's go ahead and create a new function to handle this task. We are going to create a function named handleMenuClick. When our sidebar is open on a mobile device, we want to close it automatically. This creates a better user experience after someone selects a menu item. This action ensures the mobile sidebar closes automatically. It happens whenever someone clicks on a menu item. We will display the title for each menu item here. This text will appear as the label for the button. Let's open our browser to see the menu items appearing in our application. We should now see the dashboard menu item highlighted as active. At this point, our menu items are not visible in the application. we must integrate the new menu component into our main sidebar layout. Let us add it to the dashboard sidebar structure now. Let's return to our app sidebar component. We will add our sidebar menu items right after the label section. These items will be placed inside a sidebar group content container. Let me import that component now. We can check our website to see the menu appear. Our menu is now fully visible on the screen. You can see the menu is now visible on our dashboard page. The dashboard menu item is highlighted as active. This indicates we are currently on the dashboard section of our application. Now let's make sure our sidebar works perfectly on mobile devices. Let us inspect our website using the browser's developer tools. We can switch the view to a mobile size. The page might need a quick refresh to update correctly. We can now see the sidebar working on mobile devices. There is currently no dedicated button to close the menu. You can close the menu by clicking anywhere outside of it. We need to add a new component specifically for mobile users. This component will display a close icon button. This button will allow mobile users to easily close the sidebar menu. Let's navigate back to Visual Studio Code now. We will create another new component file for our sidebar. Let's create a new React component as a functional component. This component needs to be a client-side component. It requires user interaction for clicking the close icon. This interaction is necessary to toggle the mobile menu's visibility. This component needs client-side interactivity. We cannot render it on the server. We need to import the X icon from the Lucid React library. We also need to import the use sidebar hook. This comes from the ChatCN sidebar library. We need to import the button component from ChatCN. This button will be used for interactive elements. We first need to get the hook from the use sidebar function. This hook provides a function called setOpenMobile. It also tells us whether the sidebar is currently in mobile view. We will check if the device is not a mobile device. We should return nothing in that case. Otherwise, we want to return a button that has the X icon. When this button is clicked, we will set the mobile sidebar to close. Our next step involves adding this component to our app sidebar. We will place the mobile sidebar close component right here. Add it immediately after the opening sidebar content tag. Now, we can check our website to see the result. Let's refresh our website and check the results. Let's refresh the page now to see our changes. Go ahead and click on the menu icon to open the sidebar. You can clearly see the navigation menu now appears. Notice we also have a small cross icon in the corner. You can use this cross icon to easily close the menu again. You have two ways to close the menu. You can click on the cross icon. Alternatively, you can click anywhere outside of the menu area. We have successfully completed the creation of the sidebar menu component. In the next section, we will add the user's credit balance. This information will be displayed prominently within the sidebar. Let's commit our progress to GitHub at this point. We will save all the sidebar work we just completed. I will create a commit message now. This message will say, add sidebar components and utilities. Let's commit these changes to our codebase now. We can then push them to our repository. That concludes our work on the sidebar menu. We will add the user credits display in the following tutorial section. In our previous section, we successfully built the sidebar user interface. In this section, we will retrieve the user's credit information. We will then display those credits in the sidebar footer. Looking at our application diagram, the first step is clear. We need to create functions to retrieve the user's credit information. Our next step involves creating a new file. We will name this file tts.ts. Let us start by creating this file right away. Let's open up Visual Studio Code. We will navigate into the src folder. Let's create a new folder named Actions inside the source directory. Inside the Actions folder, we will create a new file named TTS. This is a server action file. We must add the useServer directive at the very top of the file. This function operates exclusively on the server side. Website visitors cannot directly access or call these functions. This provides a significant security benefit. This security measure keeps our user data protected. These functions are completely inaccessible from the client side. Let us begin by creating our function. Let's create a function to get the user credits. This will be called getUserCredits. We should use caching for this function. This will store the user credits temporarily. It prevents making repeated requests to the database. We want to avoid fetching the user credits every single time. We will retrieve the user credits just one single time. This data will then be cached for future use. Caching the data prevents us from making excessive requests. This function is designed to be asynchronous. It will pause execution until it completes its task. Inside our function, we will implement error handling. We're going to add a try and catch statement. First, inside our try block, we need to retrieve the user's session. We will retrieve the user session next. We can do this by calling the getSession method. This method comes from the Better Auth library. We need to import the auth function. We need to import auth from the lib folder. We also need to import headers from the nextHeaders module. We will use the getSession method to retrieve the session. If we cannot retrieve a user session, that person is not authenticated. We will return a success status of false. We will also include an error message stating the user is unauthorized. The returned credits value will be set to 0. Now that we have an authenticated user, we can retrieve their credit information from the database. We need to import the database connection. This is essential for retrieving user data. We will use the database to find a specific user. We call the findUnique method on the user table. This method requires the user's ID from the session. We then specify to select only the credits field. If our query finds no user in the database, we will return a failure status. This response will include a user not found error message. We will also set the credits value to 0 for safety. If the user exists, we return success as true. We retrieve the user's credit value from the database. Inside the catch block, we will log the error to the console. We then return a failure status with an error message. The message states that we failed to fetch the credits. We also return a default value of 0 credits. Our getUserCredits function is now fully implemented. This server action securely retrieves the user's credit balance. Now we can use this function to retrieve the user's credit information. We will display this data directly within our sidebar component. Now we will create a new component to display the user credits. This component will be placed inside the sidebar folder. We will name this file credits.tsx. Let's start by creating a React functional component. We will import the coins and sparkles icons from Lucid React. We also need to fetch the user credits using our new function. Now, we will retrieve the user's credit information. We do this by calling the function we just created. We are using the await keyword for this function call. We must change our function to be asynchronous. We create a new constant and name it credits. We check if the result was successful. If it was successful, we retrieve the credits value from the result. Otherwise, we default the credits value to 0. The component will now return a simple piece of code. It includes icons for coins and sparkles. It also displays the user's credit value. Finally, it shows the word credits next to the number. Our credits component is now ready for use. We should place it inside the sidebar component. Let's navigate to the app sidebar component file. We will place our credits component inside this div element. It should go right after the opening tag for the sidebar footer. Next, we need to import the credits component we just created. Let us navigate back to the credits component file. we need to ensure we export it using a capitalized name. This component looks correct and ready for export. Let's navigate back to our sidebar component file. We need to import the credits component we just created. We can now check our application to see the credits displayed. Let's navigate back to our main application interface now. Let's refresh the application page to see the changes in action. We are encountering an error message. It says, "The system cannot resolve the Prisma module." It looks like we have an import issue in our database file. Let's open up the db.dats file to investigate this problem. We need to check the db file. Let's delete this import and try to auto-import the correct one. Let us refresh the page to see the updated credits. You can now see the user's credits displayed in the footer. The current balance shows 10 credits. New users receive 10 credits to start with upon signing up. This initial balance allows them to try the service immediately. Let's navigate back to the Neon database interface. We will manually change the user's credit value. We can update the credits field to a new number like 50. Remember to save this change in the database. Now, let's refresh the page to see the change. We should see 50 credits displayed in the footer. We have successfully added the user credits display to the sidebar footer. This feature is now fully integrated and working. Let's commit and push this new credits feature to our GitHub repository. Let's commit these changes to our local repository. After that, we will push the update to our GitHub repository. Our next section focuses on building the upgrade button. We will integrate it to let users purchase more credits. In the next section, we will integrate the Polar service. This will allow users to upgrade their account and purchase more credits. I will see you in the next part of our tutorial. We successfully built the credits functionality in our previous section. Everything for handling user credits is now fully implemented and working. Now we will focus on implementing the upgrade button. This button will let users purchase more credits. For handling payments and upgrades, we will use a service called Polar. Let's open a web browser and search for Polar. Your first step is to navigate to the website polar.sh. Before you proceed, please ensure you have logged into your Polar account. The service is completely free to use. It is also available in most countries. You might know that Stripe has limited availability. Polar, however, is accessible almost everywhere. The very first step is to access the sandbox environment. This is a testing mode that is perfect for development. The sandbox mode functions identically to the live production environment. This mode is specifically designed for testing purposes. You can just click here on this button. Then you will go to create a new organization. Let's choose a name for our organization now. For this example, I will name our organization AI Voice Studio. We can skip this onboarding process for now. Then we will navigate to the product section. We will now add 3 distinct products to our organization. These products will represent different credit packages for our users. Now we can proceed to add our first product. Let's call this first product the Small Pack. It will give users 50 credits. We are setting this up as a one-time purchase. For the pricing type, we will select Fixed Price. Let's set the price at $4.99. We will create this product now. Next, we are going to create a Medium Pack. This pack will give the user 200 credits. Let's set the price for this medium pack to $14.99. Then we can create the product. Now we will create the large pack. This pack includes 400 credits for users to purchase. For the large pack, we will set the price at $19.99. Then we can create this product. Our next step is to install the Polar SDK into our project. This will allow our application to handle payments and credits. We can integrate Polar with our application. This integration works through Better Auth. Now we will navigate back to the Better Auth website. Once there, we need to find the third-party integration section. Let's find Polar in the authentication section. We can click on it to add Polar to our authentication setup. The very first step is to install the necessary packages. We will install 2 packages to integrate Polar. The first package is Polar SH Better Auth. The second package is Polar SH SDK. Let's copy this installation command to our clipboard. Let's head back to our Visual Studio Code editor. We need to clear out the terminal first, then we can paste that installation command right in there. Actually, we need to add npm install to the beginning of this command. Our next step involves retrieving the environment variable from our project. Let's add this Polar access token to our environment variables. Our next step involves retrieving the Polar access token. You can find this token on the Polar website. Let's navigate back to the Polar website. Next, we need to navigate to the settings section. You can find this in the Polar dashboard. We will scroll down through the settings page. Then we can create a new access token. Let's name this token AI Voice Studio. We will set the token to have no expiration date. Then we can select all the available scopes for full access. Once that is done, we can proceed to create the token. Once you have created the token, you can copy it immediately. You should then go back to your environment variables file. You must also add this token to your environment type definition file. This step ensures your application remains type-safe. We need to add the Polar access token after the Better Auth URL. This token should be a string value. You must also define this token inside your runtime environment. Let us take a look at the Better Auth website again. We need to add the Polar integration to our project's auth settings. Let's return to our Visual Studio Code editor now. We need to make some changes to our auth.ts file. Next, we navigate to the auth.ts file. We must import Polar from the Polar SDK. We also need to import checkout, Polar, portal, and webhooks from Polar Better Auth. Next, we need to define our Polar client. This client will handle the connection to the Polar service. We need to access our access token for Polar. We created this token earlier inside our environment file. We also need to import the environment variables for this configuration. We are currently operating in sandbox mode for our server. This sandbox environment is specifically designed for testing purposes. Looking at the Better Auth documentation, we must add a specific plugin. This plugin integrates Polar directly into our authentication system. We need to define our checkout process and list the available products. We also need to set up webhooks to handle payment notifications. Let's go back to our Visual Studio Code editor. We will add the plugin right after the email and password configuration. This goes inside our Better Auth setup. I will now paste the plugin code into our configuration file. This plugin integrates the Polar functionality into our application. It allows us to handle purchases and manage customer accounts seamlessly. We will now initialize and use the Polar client in our configuration. When a user signs up with Better Auth, we automatically create a corresponding Polar account for them. This ensures their purchase history is properly linked. For the checkout process, we want to include all 3 of our products. These are the small, medium, and large credit packs. Our next step involves gathering the product IDs for each credit pack. You can find these unique identifiers directly in the Polar dashboard. Let's navigate back to the Polar dashboard. We are going to find the products section. Now, we need to get the product IDs from the Polar website. Let's copy each product ID from our list. We can just click here and get the product ID. After a successful payment, we will redirect the user to their dashboard. We ensure that only authenticated users can make purchases. Our system also includes a customer portal for managing orders. We will create a customer portal for Polar shortly. For now, we are adding the placeholder here. We also need to configure the webhooks. Webhooks will automatically trigger an API route in our application. This happens as soon as a purchase is successfully completed. To make the webhooks function properly, we must first create a webhook secret. This secret is generated within your Polar account settings. Let's navigate back to the Polar dashboard. We need to go into the Settings section. Then we will find the Webhooks menu. The next step is to add a webhook endpoint. We need to provide a URL for Polar to send notifications. There is one crucial point to understand about Polar. It cannot process webhooks from a local development URL. Webhooks require a publicly accessible internet address to function properly. We must install a third-party package called ngrok. This tool creates a real public URL for our local server. This is necessary because Polar requires a live web address. Let's search for ngrok on Google to find the official download page. Let's head over to the official website for ngrok at ngrok.com. For the installation process, signing up is not required. Let me search for how to download ngrok directly instead. The next step involves downloading the software. You will need to select the version for your specific operating system. Since I am using a Mac, I will download the macOS version. I will copy this installation command. Then we can navigate to our terminal. I will now paste this command into the terminal to install ngrok. This command will install ngrok on my computer. It sets up the tunneling software we need. Once the installation finishes, we are ready to create our endpoint. We need to copy this command from the ngrok documentation. After copying, we will return to our terminal application. Our port number is localhost 3000. We need to specify this for the tunnel. Our application is currently running on localhost port 3000. We need to modify our ngrok command to expose this port. The command we will use is ngrok http 3000. Let's navigate back to our terminal window now. Excellent. ngrok has now generated a public URL for our local server. I will copy this unique URL that ngrok generated. Then I will paste this URL into Polar's webhook settings. Now we need to add our webhook endpoint. The endpoint should be /API/auth/polar/webhooks. For the data format, we will select the raw option. Then we need to choose the specific event to listen for. We will use the order.paid event for this. Let's go ahead and create that webhook endpoint now. After creating the webhook, copy the secret key. You should add this secret to your environment variables file. We will call this environment variable the Polar webhook secret. Let's add this secret to our example environment file. We should also ensure it is type safe within our environment configuration script. Our code should be error-free at this point. The environment variables are now properly configured. I will now update the environment variable file with this new value. Excellent. The environment variables are now properly configured. We can see that the previous error has been resolved. When an order is paid, we want to send a signal back to our application. This lets our system know the purchase was successful. If there is no customer ID, we will log a message to the console. The message will state that no external customer ID was found. Otherwise, we will first retrieve the product ID. Then, we will grant the user their purchased credits. We will start by creating a variable named credits to add. We will set its initial value to 0. Then we check the product ID. Based on the ID, we will assign the user a specific amount of credits. This could be 50, 200, or 400 credits. Now we need to modify the product IDs from Polar. Let's navigate back to the Polar website. We need to go into the product section. There, we will find and copy the unique product IDs. Once the payment is successful, we need to update our user's information. We will add the purchase credits to their account in the database. We need to import our database connection here. Then, we want to find the user in the database first. After that, we can add the credits to their account. We want to add these purchase credits to the user's account balance. This will update their total available credits immediately. Let's test our setup by creating a new user account. We need to verify this user appears in the Polar customer list. This confirms our integration is working correctly. Let's return to our application now. Let's log out of our current session first. We will create a brand new user account for this test. I will use a real email address for this test. I need to check my Polar account for the correct email. Let's begin by creating a new user account for testing purposes. After we create a new user account, we can navigate to the Polar dashboard. When we check the Customers section, the new user appears there as well. Every user who signs up for our application is now connected. We have access to their email address and purchase history. This integration provides us with complete customer data. Our next step involves adding a purchase button to the application. This button will redirect users to the Polar payment page. We need to create a new component now. We will place this component inside the sidebar folder. Next, I will create a new component for the upgrade button. This component will be named upgrade.tsx. Let's create a React functional component. This component needs to be a client-side component. The upgrade button requires interactive functionality that only runs in the browser. We also need to remember another important step. We must add this same plugin to the client side. Next, we need to go to the auth client file as well. We should add this same plugin at the bottom of that file. This essential import comes directly from the Polar Better Auth library. Now we can proceed with building our upgrade component. We will implement the functionality for users to purchase additional credits. Let's create a function to handle credit upgrades. We will use the auth client we set up earlier. We also need to include our product IDs here. Let's navigate back to the Polar dashboard. We need to copy the product IDs for our packages. Now, let's define what this button will look like. We will return a simple button element from this component. We need to import the ChadCN button component. We will create a button labeled Upgrade. This button will call a specific function when clicked. The function initiates a checkout process for the selected product. We also need to import icons from Lucid React. We will use a crown and sparkles icon for the button. Let's get this upgrade component finished up. We can then add it to our sidebar. Let me just delete that extra parenthesis we have here. We have completed the upgrade component file. We can now add it to our sidebar. Let us place it right after the Create button. So now, let's check our application. We can see the upgrade button is now displayed in the sidebar. Let us refresh the page first. Then we can click on this upgrade button to test it. Let's select the small pack for this demonstration. We will use the Test Credit Card Payment option. This is specifically designed for testing purposes. You can see the name field is already filled in here. For the country field, you can enter your own location. For example, you could select Australia. You can also use a discount code if you have one available. One great feature of Polar is the ability to create discount codes. This allows you to offer promotions to your customers. Let me demonstrate how you can create a discount code within Polar. To create a discount, navigate to the Discounts section. You can find it in your Polar dashboard. Let's create a new discount code for our customers. For this example, we will create a 20% discount. For the discount code, we can use something simple like new20. This code will apply a 20% discount to the purchase. We can create that discount code now. Our customers can start using it for their purchases. Let's go back to our checkout page and test this discount code. We can see the discount has been successfully applied to our order. Now we are ready to proceed with the payment process. After you complete the payment, you can see your credits have updated. You started with 10 credits, and now you have 60. You will receive an email from Polar with AI Voice Studio title. This email contains your order confirmation. You now have 50 additional credits available. You can click right here to view and download your invoice. The website owner also receives a confirmation email for the purchase. You can see we received a congratulations email. This email confirms the purchase of a small pack. The amazing part is Polar handles many website needs automatically. It even sends confirmation emails for you. Our next step involves creating the customer portal. Currently, we have not implemented the customer portal feature yet. Let's take a look at the project diagram. We need to see what we are building next. To create the customer portal, we must add a new folder. This folder will be named Customer Portal. You should place this folder inside the dashboard directory. We are going to create the page.tsx file now. This will give us the customer portal page. The root will be /dashboard/customer portal. Let's begin by creating the folder for our customer portal. We will place this new folder inside the dashboard directory. Let's return to our Visual Studio Code editor now. Let's head back into our Visual Studio Code editor. We need to navigate to the dashboard folder. Next, I will create a new folder named Customer Portal. Inside this folder, we will add a file called page.tsx. This file will contain a React functional component. We will call it page for now. This component is designed to be asynchronous. It operates on the server side. We need to retrieve the user's current session information. This data comes from our Better Auth authentication system. We also need to import the headers function from Nextjs. Now we need to set up a basic condition here. We need to check if the user has an active session. If no session is found, we will redirect them to the sign-in page. We need to bring in the redirect function from Next.js navigation. This will help us manage page redirections in our application. At this point, we will return a component named Customer Portal Redirect. Our next step involves creating this component. Let's navigate to the Components folder. We are going inside the sidebar directory. Next, I will create a new file for the Customer Portal Redirect. This file will be named Customer Portal Redirect.tsx. Let's build a React functional component to handle this task. Now, we need to import this newly created component into our file. This customer portal page has an important job. It verifies whether a user is properly logged in. Once the user is authenticated, we will redirect them to their customer portal. Let's finish building out our customer portal component now. We need to make sure it properly redirects authenticated users. We need to make this a client-side component. This is necessary because we are using a React hook. We'll be adding a user effect, React hook, to this component. We need to import the useEffect hook from the React library. We also need to import the authClient from our authClient module. We use a method named portal from our client setup. This redirects the user to the Polar payment interface. This component will check the user's authentication status. It will then redirect them to the Polar customer portal. While this process happens, we display a simple loading indicator. We are using the loader component from the Lucid React library. While the customer portal loads, we want to display a loading indicator. This provides visual feedback to the user. Let us test this customer portal in our application now. We can see if the redirect works correctly. Let's navigate back to our main application website now. Now let's check our application's sidebar. When you click on the customer portal, you will first notice a loading indicator. After a moment, you are taken directly to your authenticated customer portal. We can see the order details here. It shows our small package purchase was successful. You can head over to the billing section. There, you can change your current payment method. You can also add a brand new one if you wish. You can also update your billing address right here. You can view your complete order history and download invoices. These invoices are provided as PDF files for your convenience. All of your account management tools are available in this single portal. The integration is now fully operational. All the payment and portal features are working exactly as intended. We have successfully integrated Polar into our application. This integration provides a complete payment solution for our users. It handles secure transactions and customer management. Let's commit our changes to GitHub to save all this progress. The commit message will state that we have integrated the Polar SDK. We also enhanced the customer portal functionality for a better user experience. Let's commit these changes to our GitHub repository. We can then push the updates to complete the integration. We are now approaching the final client-side feature. The only remaining item on our list is the settings page. We will finish up the settings page next. After that, we will shift our focus to the backend development. That covers everything for integrating Polar into our application. We will see you in the next section for the next steps. In the previous section, we finished building the upgrade feature. In this section, we are building the settings page. This page lets users manage their personal account details. Our next task is to create the settings page for our application. If you check the eraser diagram, you will see the process. We can create the settings page quite easily. You just need to create a folder named setting. Then inside that folder, create a file called page.tsx. Let us begin by creating that folder and file. Let's navigate back to the File Explorer. This folder is named Settings. You can see it right here. Let's return to our Visual Studio Code editor. We will navigate to the Dashboard section of our project. Let's create a new folder named Settings. Inside that folder, we will create a page.tsx file. First, we will create a React functional component. We are doing this to get the basic page structure in place. We will name this component the Settings page. Let's check our application to see the new page. We will use a pre-built component called the Account Settings card. This component provides all the essential user interface elements. You will get an avatar display, name, and email fields. It also includes an option to change your password. We will mark this component for client-side use. We need to import 4 specific components from Better Auth UI. These components are Redirect to Sign-in and Security Settings card. We also need the Sign-in component. Finally, we must import the Account Setting card. We also need to import a component called Loader from Lucid React. This will show a loading animation while the page is getting ready. We need to use the Auth client we set up earlier. This client will help us get the user's session information. We also need to import 2 important hooks from React. We need the useEffect and useState. We are going to start by creating a state variable called isLoading. We will set this initial value to true. We will now use the React useEffect hook. This hook will check the user's session status. We will check the user's session to verify everything is working correctly. We need to ensure the session is valid. We check if there is no user session. We should throw an appropriate error here. After confirming everything is working correctly, we can set the loading state to false. After the useEffect hook runs, we need to add a conditional check. While the page is still loading, we should display a loading indicator. This provides feedback to the user. Otherwise, we will return the actual settings page content. The settings page itself is straightforward to set up. First, we need to check if the user is logged in. If they are not, we should automatically redirect them to the sign-in page. If the user is signed in, we will display the settings interface. We will start by adding a header for the account settings. This header will explain you can manage your preferences. Then we will use the account setting card from Better Auth. We will also include the security settings card. These components display all the relevant account management features. Let us take a look at our application to see the results. You can now see the header at the top of the page. You also have the ability to change your name. You can update your email address as well. There is an option to update your password. You can also view your active user sessions here. You will also find a logout button on the page. This allows you to securely sign out of your account. The settings page is now fully functional with all the required features. That was a very straightforward process. We simply use this account setting component from Better Auth UI. It adds all the necessary features to our application. Let's save our progress by committing the new settings page. We will push all the account management features to GitHub. Let's commit these changes to our local repository. We will then push them up to GitHub. In the upcoming section, our focus will shift to the backend. We will build the server-side logic for our project. Let's get started with the AWS setup for our project. We will be creating our cloud storage in this section. We are going to create our storage inside Amazon AWS. The very first step is to search for AWS sign-in. Now, we need to click on the AWS Management Console link. After that, you will click on the Sign In button located there. The AWS account is free to sign up for. They provide you with free credits to get started. For example, AWS offers $100 in credits for new accounts. You can use these credits over your first 6 months. They also include free tier services each month. This means you can test your application without paying anything. Now, you just need to click on the S3 service. Our next step involves creating a new S3 bucket. This bucket will store all of our application's audio files. We are going to click the Create Bucket button. This will start the process of making our new storage. Let's name our new bucket AI Voice Studio. I will add my name to the end of the name. The bucket name must be completely unique across all of Amazon services. You cannot use a name that someone else has already taken. If the name is already taken, try adding some numbers. This will help create a unique name for your bucket. We will now configure the object ownership settings. We need to set the ACLs to disabled. We are going to uncheck this block public access setting. This ensures our audio files will be publicly accessible. People will be able to download and listen to the files. Next, we will set the bucket versioning option to disabled. We will leave all other settings at their default values. Finally, we click the Create Bucket button to proceed. We must click this checkbox to acknowledge unblocking public access. Then we click the Create Bucket button again. Our new bucket has been successfully created. We can now proceed by clicking directly on its name. To keep our audio files organized, we should create a few folders. This will help us manage our storage effectively. To organize our storage effectively, we need to create 3 separate folders. We need to create one folder specifically for our text-to-speech model. This folder will store all the audio files it generates. Let's name this folder TTS for our text-to-speech output. Let us proceed by creating our first folder. Let's create a new folder for this. We will name this folder TTS. Our next folder will hold sample voice files. We will provide these audio samples for users of our website. Let's create a folder named Samples. Inside this folder, we will make another folder called Voices. We also need to create a main Voices folder at the root level. This folder will store the voices that users upload for their own personal use. We will create a folder inside this Voices directory. Each user will have their own personal folder. These folders will be named with the user's unique ID. This is where we will store their uploaded voice files. In contrast, the sample folder will contain our own pre-recorded voices. These preloaded samples will be available for everyone on the website. Let's upload a voice file now as an example. This will show you how the process works. Let me upload this sample voice file as a demonstration. Let me show you a specific issue we need to address. Let's copy the URL of this voice file we uploaded. Next, paste that URL into your browser's address bar. We receive an access denied error message. This happens because the files are set to private by default. public access is blocked for security reasons. To fix this access issue, we need to grant public read permissions. We will add a new bucket policy rule to allow this. Let's head back to our folder in the S3 bucket. We are going to add some permission rules there. We will now modify the bucket policy. Please click on the Edit button. We are going to add a brand new policy statement. We will create a statement for public read access. This allows anyone to view the objects. This policy will apply to everyone who needs to access our files. For the principal field, we enter an asterisk to represent everyone. Then we move to the Action section. We select the S3 Get Object action for this rule. We need to specify our bucket's unique identifier. This identifier is called ARN. We copy this ARN string and paste it into the resource field. We also need to add an asterisk at the very end. This policy will apply to all subfolders within our bucket. Every file inside them will have the same public get permissions. Let's go ahead and save these new policy changes for our bucket. Let's refresh this browser page to test our changes. You should now be able to access the audio file directly. You can see the file is now accessible. It is ready to play back the audio sample. Our next task involves creating a dedicated user within our AWS account. We will then assign a specific policy to this user. The policy we created earlier only handles read permissions. We need a more comprehensive policy for broader access. We need to add permissions for other operations. These operations include deleting and uploading files. We will now search for IAM in the search bar. We should open the IAM service in a new tab. Navigate to the Users section within the IAM dashboard. Let's proceed with creating a new user for our application. Let's name this new user AI Voice Studio Backend. Let's click on the Next button. We need to attach a policy to this new user. We will now attach a policy directly. We are going to create a brand new policy for our user. For the service selection, we are going to choose Amazon S3. We search for the list bucket action. We need to add that to our policy. We have added the first action to our policy. This action allows our application to list the contents of the bucket. Next, we need the get object action for reading files. We also require the put object action for writing files. We now have 3 distinct permissions added to our policy. These actions cover listing, reading, and writing objects. Now we can scroll down to the Resources section. We need to add a specific resource for our bucket. This means we will provide the ARN for our own bucket. We want to add the ARN for our specific bucket. We will click on the ARN field. Then we paste the ARN we copied earlier. We copy this exact ARN from our bucket policy. We then paste it into the resource field for the object. We need to specify our bucket name right here. Then we want to select the option for any object. This action ensures every object within the bucket inherits the same permissions. Now we proceed by clicking the Add ARN button. Now we can proceed to the next step for naming our policy. We will select the policy named AI Voice Studio Backend Policy. After that, we can click the Create Policy button to finalize it. Our custom policy has been successfully created. We can now attach it to our user. Our next step involves assigning this policy to our user account. We need to return to the previous browser tab. We were just in the middle of creating our user. We need to refresh the page first. Then we can search for our new policy. Look for the policy named AI Studio Backend Policy. We do not need to click on the policy itself. We just need to select it from the list of available policies. Please verify that the policy name is correct. After confirming everything looks good, we can select it. Then we proceed to the next step. We can now see the permission summary page. Our new policy has been successfully attached to the user. We can now proceed with creating the user. Simply click the Create User button. We have now created our new user. Next, click on the username to open its details. Here, we can generate an access key. This key must be saved securely within our application. We are going to create an access key for this new user. We will select the Others option for the use case. Then we proceed by clicking the Next button. Finally, we confirm the creation of the access key. We can copy this access key and secret. We should then navigate back to our environment file. We will add these credentials there for our application to use. Next, we navigate to the frontend project. We will open our environment file to add the new credentials. We need to add 4 specific configuration values here. These values are essential for connecting our application. Let me paste the template we need into the environment file. We need to set up 4 specific AWS credentials. You will need the access key ID and the secret access key. You also need to specify your AWS region. Finally, you will need your S3 bucket name. Let me add this configuration to our example environment file as well. This will help anyone following along with the tutorial. Let me show you where to find the bucket name. You can see it displayed right here on your screen. This is the name of our S3 bucket. You will need this exact name for your application configuration. You can copy this bucket name directly from the screen. Simply copy this text from your screen. You can then paste it directly into the correct field. You can find the region information right here. It is displayed in the console's upper right corner. You can see the region code displayed right here. This is the code you will need to copy. You can find your region code in this menu. Just choose the region that is geographically closest to you. I will copy the region code and paste it in the region field. The access key ID and secret access key are found here. Next, we must include these specific values within our TypeScript environment file. Each of these environment variables should be defined as a string. They are all optional for the configuration. We must also add these variables to our runtime environment. This ensures our application can access them properly. The AWS Setup is now fully configured and ready to use. Your storage bucket and user permissions are all in place. Let's commit these changes to our Git repository. We will add the environment variables file to version control. I will now make a commit with the message AWS Setup. After that, we can push our changes to the repository. In our next section, we will continue developing the project's backend. We will add more functionality to our application. We just finished setting up our AWS environment in the previous section. In this section, we will install our text-to-speech model. We will then add it to a service called Modal. We will deploy our model on this service. Then we can run our text-to-speech generation. We will use the generated audio in our front-end application. Now let me show you exactly which model we will be using. I will open Google and search for the Chatterbox model. This is the specific open-source model we will be using for our project. For more details about this model, you can visit the Resemble website. This model is completely free to use and carries an MIT license. It supports many different languages with multilingual capabilities. You also get motion control features for dynamic voice output. It operates at incredibly fast speeds for quick results. It even outperforms paid services like 11 Labs in quality. You get superior performance without any cost whatsoever. You can see examples on this page and test the model yourself. For our tutorial, we will click to visit the GitHub page. There you will find the complete installation instructions. We need to install the model using this specific command line utility. We will not install it on our local computer. Instead, we will install it on a remote GPU service called Modal. Let's search for the Modal platform online. You can navigate to modal.com in your web browser. Modal is a high-performance AI infrastructure platform. It provides dedicated GPU resources for running AI models efficiently. This infrastructure provides dedicated GPU power for your model. It only runs when you make a request. This means it stays offline and costs nothing when idle. When you call it, the service loads the model onto the GPU. This platform uses a serverless model. It can handle any kind of AI service you need, Let's click on that button to get started with the platform. When you first log into Modal, you receive a monthly credit of $30. This free credit is provided every single month for your use. Modal provides you with $30 in free credits each month. This means you get access to 10 powerful GPUs. You can also run up to 100 separate containers. I will explain what these resources mean later in the tutorial. This monthly credit is more than sufficient for testing your application. It is actually quite generous for development purposes. This current billing period is already 17 days in. My current usage is only about $2.50. You will never need to pay anything for this service. This is especially true when you are testing your own application. The free monthly credits are more than enough. The initial step involves navigating to the Secrets section. You will add your AWS credentials there. The next step involves creating a new secret. We will add our AWS credentials here. You can name this secret anything you prefer. For this example, let's call it AI Voice Studio AWS Secret. Now, you can add all the AWS credentials you currently have. We've already stored these values in our environment variables. Let's copy these values from our environment variables. We can paste them directly into these fields. We also need to add another field for our AWS S3 bucket name. This is the specific name we created earlier. Let's save those secrets to keep our AWS configuration secure. This secret is now safely stored and ready for use. Let me explain how we use this secret inside our function. We simply pass the secret as a parameter. Then, we can access the credentials whenever we need them. We pass the secret to our function initially. Then we can access it whenever needed. This allows us to use our credentials securely in the application. Let's navigate back to our Visual Studio Code editor. We are going to open the backend folder now. Next, we will create a new directory. This directory will be named text-to-speech. Inside that new text-to-speech folder, we will create a requirements file. This file tells the system which Python packages to install. This file lists all the packages our installation needs. It specifies exactly which dependencies must be installed for our project. The first package we need to install is called Torch Audio. It is used for audio processing tasks. This includes reading and writing audio files. It supports various audio formats. The next package we need is called Modal. It specifically provides GPU support for our application as mentioned earlier. Next up, we are going to use the Pydantic library. Pydantic is a data validation library. It ensures all API requests and responses have the correct format. This prevents errors in our application. We will use FastAPI to build our REST API endpoint. The request library helps us make API calls. This is especially useful for testing our script. Next, we need to add the main package for our text-to-speech model. This is the Chatterbox TTS library. This is our main model, the Chatterbox Multilingual Text-to-Speech System. It will handle converting our text into spoken audio. As we can see in the Chatterbox documentation, we need to install this package here. Now we can create our new text-to-speech file. We will call this file tts.py. We are going to create our serverless API endpoint now. This endpoint will handle the text-to-speech requests for our application. Before we go any further, we should set up a Python environment in our backend directory. This will help manage our project dependencies. Before we move forward, please ensure you have the necessary extensions installed. You will need to install the Python extension for Visual Studio Code. This includes the Python environment and debugger. You should also install the Pylons extension. First, ensure you have all those extensions installed. Then, inside your terminal, you should stop the current server process. Let's navigate back to our project. We need to go into the backend folder now. Make sure you are currently inside the backend folder. We've already navigated into that directory. I will copy this command for us to use. Next, you need to run the Python 3 command to create your environment. After that, You will run the source command to activate it. You can see, we are now inside our virtual environment. You should see these parentheses appear in your terminal. This confirms your virtual environment is active. You will also notice a new folder has been created. Next, we need to install the Modal SDK into our backend application. This step allows our code to communicate with the Modal platform. Let's head back to our browser and open a new tab. We will search Google for the official Modal documentation. We can navigate to the Guide section on the website. Then we will find the Installation tab there. Let's scroll down the page a bit. We are looking for the Getting Started tab. The first step involves installing the necessary package. We will use the pip command to install Modal. Before you can use pip, you must first activate your virtual environment. Once you have your virtual environment activated, copy this installation command. Then paste it directly into your terminal window. The Modal installation process has finished successfully. We are now ready to proceed with the next configuration step. Our next step is to configure the Modal setup. Next, we need to run the Modal setup command. This will create an API token for our account. This command will generate an authentication token for your account. You just need to click on the Authorize button. This will create the API token for you. Your API token has been successfully generated at this point. The authorization process is now complete. You can see the API token has been successfully created here. Now let's move on to writing our text-to-speech Python file. We need to create the main serverless function. First, we need to import the I/O module. This module helps with in-memory file operations and creating audio buffers. The I/O module handles in-memory file operations. It helps us create audio buffers without writing to disk. Next, we have the OS module. It handles file system operations. This includes checking if files exist. It also manages creating new directories. We use the sys module to access system-specific parameters and functions. This helps our code interact with the underlying Python runtime environment. Next, we will import the typing module. We specifically need to use the from typing import statement. We import the optional module from typing. This gives us type hinting capabilities. The optional type hint allows a value to be none. This means it can be omitted entirely. Next, we will import the UUID library. This tool creates unique identification codes for our audio files. These unique names prevent any file conflicts in our system. Next, we need to import the Modal SDK that we installed earlier. This SDK allows us to create serverless functions that run on GPUs. Next, we need to import the base model class from the Pedantic library. This class is essential for defining our data schemas. This component handles defining your data structures. It automatically validates that the data you receive matches the expected format. Now we need to bring in some external libraries. These are for machine learning tasks and for handling audio processing. Our first import is for Torch. This is the main PyTorch library. Seeing those import errors is completely normal at this stage. We have defined these dependencies in our requirements file. They will be installed automatically when we deploy our function later. We've already listed these packages in our requirements for installation. They are not installed on our system just yet. We need to import the PyTorch library for our text-to-speech model. We also require the Torchodio library. This Torchodio library handles loading and saving audio files. Our next step involves creating a Docker image. This image will run our code. This Docker image comes with Python and PyTorch pre-installed. It also includes all the other dependencies required for our text-to-speech functionality. We are going to define our Docker image. We start by opening a set of parentheses. This image will be based on a Debian Slim Linux distribution. It will also have Python version 3.11 pre-installed for us. We also need to install a few additional packages. These are prerequisites for our main installation. They are necessary for the application to function correctly. Before we install our main requirements, we need to handle a few prerequisites. We will do this by running a pip install command. First, we need to install NumPy version 1.26. This is a required package. We also want to install PyTorch next. We will start by installing PyTorch first. After that, we will proceed to install the Torch audio library. Installing Torch is a necessary prerequisite for our setup. We will be using Torch version 2.6.0 specifically. This version is required for compatibility with our text-to-speech model. After we install these prerequisite packages, we will install our main requirements. Next, we will install all the required packages. We do this by running the pip install command. This command will read from our requirements.txt file. This file is located right here in our project. Next, we will install ffmpeg. This package is essential for audio processing tasks. We need to install ffmpeg for audio processing. It handles various audio formats and conversions. That covers everything we need for our Docker image configuration. Next, we will create a persistent volume. This volume will cache our model files. This prevents having to download the model again for every request. It saves us time and resources. This persistent volume prevents us from downloading the model every single time. We will create a persistent volume for caching our model. We are going to assign a specific name to this persistent volume. We will name this volume hfcache. This is where we will store our model files. For example, we can name this volume Chatterbox. Another good name would be AI Voice Studio. This volume will only be created if it does not already exist. We set the create if missing option to true. This ensures the volume is created automatically when needed. Now we need to reference the secret we just created. This will give our function access to the AWS credentials. We will name this s3_secret. You should use the exact secret name we created earlier. Let's navigate back to the interface. We need to go to the secret section now. Here is the secret we just created for our AWS credentials. Let's copy the secret name we created earlier. You can see it right here. Now we will paste that name into our code. Let's define the structure for our API request. We need to specify what data our text-to-speech function expects to receive. Let's define the request schema for our API. This specifies what data the API expects from the client. For our text-to-speech function, we can include several different input values. These values allow you to control how the final audio will sound. We need the text content you want to convert. We also need to specify the language for the synthesis. We can also adjust the weight and exaggeration settings for the voice. These parameters give us more control over the final audio output. This defines the structure of the data our API expects to receive. It outlines the required fields for the text-to-speech request. Let's switch back to our Visual Studio Code editor now. Next, we will create a class named text-to-speech request. We will use the base model we imported earlier. This class will define our schema for the request. The schema includes a text field. This field is a required string. It contains the text we want to convert into speech. We also have an optional voice S3 key. This allows us to create a voice without a reference. This field is for the cloning voice reference, and it is optional. We define it as an optional string. By default, this value will be set to none. Next, we define the language field, which is also a string. We set its default value to English. Then we have the exaggeration parameter. This value is a floating point number. We use a float for decimal values. The default value is set to 0.5. The CFG weight is also a numerical value. Its initial value is 0.5. This parameter controls the speed of the speech. It also determines how closely the voice matches your reference sample. Now, we need to define the schema for our API. This schema outlines the exact data structure our function expects to receive. This defines the schema for the data that our API returns to the client. It specifies the structure and format of the response. We need to define what our API will return to the client. We will call this the text-to-speech response. The response will contain an S3 key. This S3 key is the address of the generated audio file. This address is the location where our generated audio file is stored. It is returned to us as a simple text string. This S3 key provides the exact location in your storage. Your generated audio files will be saved there. We must define the serverless function class next. This class will configure our GPU settings. It also handles our storage requirements. We need to select the specific GPU type for our deployment. We also need to define the path for our persistent volume. Finally, we must specify the address for our AWS S3 key. Now we will define our serverless function class. We need to add the decorator for this function. We are going to use the Docker image we defined earlier. This image contains all the necessary dependencies. Next, we will specify the GPU settings. We will use the L40S GPU for our model. This specific GPU is perfectly suited for our testing needs. It offers excellent performance for our application. Now let's look at the Modal platform's GPU options. Modal offers several different types of GPU for you to choose from. For our testing purposes, we are using the L40S GPU. Choosing a more powerful GPU will increase the cost of the service. However, it will also significantly improve the speed of the processing. This particular GPU option provides sufficient performance for our testing needs. It delivers quite impressive speed for our text-to-speech tasks. The L40S GPU is perfectly sufficient for testing our application. It provides excellent performance for our needs. You will find the processing speed to be quite impressive. Next, we need to configure the volume address and other related settings. We want to configure our storage volumes. We will set volumes equal to a new object. We want to save our model files to the root directory. The specific path is the .cache hugging face folder. This location will be equal to the volume we created earlier. This volume allows our service to read voice samples for cloning. It also handles writing the final generated audio files to our storage. Next, we need to set up the S3 mount path. This path will be set to modal.cloud bucket mount. We also need to specify the exact name of our S3 bucket. You can find this bucket name in your AWS account. Go ahead and copy your S3 bucket name from the AWS console. Then paste that name right here in this field. This step ensures we pass the secret data correctly. We have defined the S3 secret right here. The model service will retrieve our credentials from this secret. We have now completed the volume configuration for our project. This step is essential for managing our model storage and data access. Next, we will configure the scale-down behavior. This setting keeps the GPU active for 2 minutes. It remains warm after the last request finishes. This helps reduce cold start delays. We will set the scale-down window to 2 minutes. This equals 120 seconds. We also need to pass our secret. This secret is the S3 secret we defined. This step injects your AWS credentials as environment variables. This allows your application to securely access the necessary cloud services. Let's add a comma right here to separate these configuration items. Next, we are going to define our server function here. This is what will handle the text-to-speech requests. We are going to define a new class for our text-to-speech server. This class will handle all the speech generation logic. We need to load our text-to-speech model directly into the GPU memory. This ensures it is ready for fast processing. First, we need to add the model to our serverless function. Next, we need to define a method to load our model. This method will be called loadModel. This method is designed to run only a single time. It will not execute on every individual request. We will import the model from the Chatterbox TTS library. Specifically, we are using the Chatterbox multilingual model. Next, we need to load the model onto the GPU for processing. We will set the model to self-model. This model is loaded from its pre-trained weights. We also need to specify the device as CUDA. This ensures the model runs on the GPU for faster processing. Now we will create the API endpoint for our text-to-speech service. This endpoint will handle the requests to generate audio. We are now going to create the main API endpoint using Fast API. We will configure this endpoint to use the post method. We also need to set up some proxy authentication for security. We will add authentication with a modal key and secret later. This will make our endpoint secure and protected. Next, we will define the function that generates the actual speech audio. This function will process the incoming request. Next, we will disable gradient calculations for the model. This saves memory and speeds up the processing. Next, we need to check for a user-provided voice sample. This is used for voice cloning. We need to check if the user provided a voice sample. We do this with a simple if statement. This checks for the voice S3 key in the request. We need to retrieve that sample voice for cloning. If the file is not found in the path, we should throw an error message. If a cloning voice is provided, we use it to generate the audio. We also apply the specified language for the generation. The exaggeration and CFG weight settings are used as well. This condition is important for handling voice cloning. It should be placed right here in the code. This condition handles the cloning voice scenario. If the condition is not met, we will add an else block. If the user does not provide a cloning voice sample, we will proceed with the generation. We will create the audio using only the provided text and settings. We just have the text, language, exaggeration, and the weight. We need to transfer this audio file from GPU memory. Moving it to the CPU frees up the GPU. This helps save valuable memory resources. We will create a new variable called wave_CPU. This step moves the audio data from the GPU to the CPU. This process helps save memory for our application. Next, we need to save the generated audio file. We will convert it into the standard WAV format for compatibility. We will use this in-memory buffer to save our audio. We will save it in the common WAV file format. We need to reset the buffer position back to the start. This allows us to read all the bytes from the beginning. The next important step is to generate a unique file name. We need a distinct name for our new audio file. We are going to create a unique file name for our audio using a UUID. This file will be saved inside a specific folder. The folder is named TTS and is located in our AWS S3 storage. You might remember that we previously created a folder in our AWS S3 bucket. This folder is specifically named TTS. We will save all of our generated audio files inside this specific folder. Next, we will save the generated audio file into our S3 bucket. We will create the directory at that path. Then we write the generated audio bytes to that location. Finally, we return the text-to-speech response with the S3 key. We will print a confirmation message. This message indicates that the audio file has been saved. It will show the full S3 file path. Our text-to-speech function is now ready. The next step is to deploy this file to the Modal service. The next step requires navigating into the text-to-speech folder. Next, we will deploy our text-to-speech application using the Modal deploy command. This step will make our API available online. Let's take a moment to check the errors we are currently encountering. I think I spotted the issue with the volume name. It looks like this needs to be in uppercase letters. Let me give this another try and see what happens. We are getting an error because the app is not defined. It looks like we used the variable name app in our code. We never actually defined that variable at the top of our script. We will now define our main application. We can do this by calling modal.app. This sets the name for our application. Let's run the deployment command one more time. We are getting an error about an unexpected secret keyword. This error is on line 38. Let me correct that typo. It should be secrets, not secret. Let's go ahead and deploy our application once more. We want to make sure everything is set up correctly. Our deployment process has completed successfully. The application is now fully operational on the Modal service. Our application is now deployed and we have a live URL. This URL is ready to be used. We can copy the deployed app URL from here, then we will navigate over to a new tab and paste it in. Our application is now successfully deployed. You can see the live URL is active and ready. We have created a specific function to handle this task. This function is called the text-to-speech server. This function is configured to run on an L40's GPU. This specific hardware provides the necessary power for our text-to-speech processing. Let's click on this function to open its details. This interface displays our function calls and containers. Our next task is to obtain a proxy token. Next, we navigate to the settings section. From there, we select the proxy auth tokens option. I will now create a brand new token here for our proxy. You can now retrieve your authentication token from this interface. Let's copy this token to our clipboard. We will navigate back to our environment file. We can paste the token there. I am updating this environment variable to uppercase. This will clearly label it as the Modal API key. We also need to add our Modal API secret key. This is another important credential for authentication. Next, we must add this URL to our environment file. This is the address we will use for our API requests. I will add this configuration to our example environment file. The API endpoint is simply a string URL. The API key is a string of characters. The API secret is also a string. Let's also define the runtime environment. This is an important configuration step. We have our URL and credentials ready for use. Let us test the setup with a simple curl request. Let me show you a simple curl request. You must provide your Modal API key. You must also provide your API secret. Then you will need the deployment URL. Finally, you will include your text input. You will also specify the language for the speech. You can find the exact curl request format in the Modal documentation. This format is available once you have your proxy tokens ready. Let's run this curl request inside our terminal. Make sure you have your own Modal key and secret ready. After pasting the command, press the Enter key on your keyboard. This first request will take a bit longer to complete. It needs to download the model from Hugging Face and install all the dependencies. After this initial setup, every subsequent request will be much faster. Let's navigate back to the Modal application. We can check the logs to see the installation progress. Let's navigate back to our application dashboard. You can go to the logs section now. We should see the installation process is currently running. You can see the system is now downloading all the necessary files. It is gathering all the required components for the installation. The installation process is currently underway. We should wait for it to fully complete before moving forward. It looks like we have encountered an error here. Let's check the logs to see what happened. Let's go back and check our application. It appears I made a typo in the S3 key name. It appears I made a typo with the S3 key. The first letter should be a lowercase for S3. We have now identified and corrected that typo. With the typo corrected, we must redeploy the application. This will apply our new changes. We will run the modal deploy command once more. This will update our application with the corrected code. I will now check if we received the same deployment URL. I want to see if it has changed at all. Let's navigate to our environment variables file. The URL remains unchanged from our previous deployment. We can continue using the exact same address for our requests. Let's run that same curl request one more time. We can test our fix with the same command. Let's run that same curl command again to test our fix. We'll use the exact same request as before. Let's navigate back to the Modal dashboard. We will check the logs section. The installation process is now underway. The system is actively fetching all the necessary files. We must wait for this download and setup to finish completely. The installation is making good progress now. It is currently sampling the audio files we need. It looks like we have encountered another error message. Let us investigate what went wrong this time. It appears I have made another typing error in the code. Let's navigate back to our application interface now. I think the issue is with the S3 key variable name. It seems I made a few typing mistakes in the S3 key. Looking at the code, the S3 key needs a capital letter here. The first S3 key variable should have a capital K. Please make sure to use uppercase K in the variable name. Let's deploy our application one more time. We need to make sure our typo fix is applied. Let us send a new request to test our corrected configuration. Let's refresh the login page to see the current status. We can check if the installation process has started properly. The installation process has now begun once more. We can observe the system fetching all the necessary files and dependencies. This time our deployment was successful. You can see the file has been saved to our S3 bucket. The address is displayed right here. Let's navigate back to our S3 bucket. Then we'll open the TSS folder. Inside that folder, you should see a new file has been created. You can see 2 files have been saved. You can now download the file that was just created. You can simply click on the file to download it. This file here is the most recent audio file we generated. Let's copy the link or download the file to our computer. The file has been successfully downloaded to our computer. We can confirm that it is working perfectly. Our Modal installation process is now complete. The system is working correctly. You will notice the first request takes quite a while. This is because the app is initializing for the first time. You can verify this by navigating back to the Apps section, then check the Logs panel. You can see the request succeeded with a status of 200. The initial startup took about 40 seconds. This is because the application had to install. It also needed time to warm up the GPU. Let me try that same request again. You will notice the response time is significantly faster now. The result should appear in just a few seconds. You can see the request has now succeeded. The entire process only took about 5 seconds this time. Let's head back to your S3 bucket. When you refresh the page, a new audio file should appear. When your application has many active users, the startup process remains very fast. The actual execution of the requests is also very quick. If our application has no users for 2 minutes, the GPU powers down. We must turn it back on for the next user. This startup process takes significantly longer. Each individual request costs roughly 10 cents. This gives you a clear idea of the operational expense. Our text-to-speech server is now fully operational. The deployment process has been completed successfully. That completes our work on the text-to-speech server. We have successfully set up the backend functionality. We now have our unique URL available. We have saved this URL securely in our environment variable file. We are ready to create the front-end page. We will use this URL to send requests to our backend. You must include the Modal API key and secret. You can see this process was quite straightforward. To avoid making typing errors like I did, you can visit the GitHub repository. You can copy the code directly from there. Let's commit our code to the GitHub repository now. We want to make sure all of our changes are safely stored. We will now add all of our project files to the repository. I want to exclude this particular file from being uploaded to GitHub. Let's take a look at this file to see what it is. We can add a file called .gitignore. This will allow us to exclude that specific file. Before we add everything to GitHub, I want to create a .gitignore file inside the backend directory. I am going to add these specific rules to it. This configuration ensures the application will ignore the Pi cache directory. This prevents it from being tracked in our version control. Let's check the file list again. You can see that specific file is no longer visible. Let's go ahead and stage all of these changes. We can add everything to our commit. Let's create a commit message for our changes. This message will describe what we've added to the repository. We will use this commit message. Then, we can commit the code and push it to GitHub. That concludes the process of creating our backend server. We have successfully set up our text-to-speech function and tested it thoroughly. Our backend is now fully set up and working. We can shift our focus entirely to the front end. We will build the user interface you saw in the final version. We will create a text input field. This is where you can type your message. You can choose from different emotional tones for your text. You also have the option to upload a voice sample. We will continue with the front end in the next section. You will see how to build the user interface. Welcome back to our tutorial on building the text-to-speech application. In this section, we are going to build the Create page together. We will construct the interface step by step. Before we build our Create page, we need to write some foundational functions. These functions will handle the core actions for our application. We need to create several functions known as actions. These actions will handle the core features of our page. Let us write the code for them now. The very first action we need to build is for generating speech. This function will be responsible for converting text into an audio file. We will also create an action to retrieve the user's audio projects. This data will be used to display their projects on the page. Next, we need to create an action for uploading a voice file. We also need another action to retrieve the list of available voices. You can see these voices listed right here. Let's switch back to our code editor now. Let's navigate into the action folder. We will open the tts.ts file next. You might remember we already created an action called Get User Credits. Our next step is to add several new actions to this file. We need to define the types for our inputs. This is for the Generate Speech function. We will specify both the input and output data types. Let's start by defining the input types for our Generate Speech function. Our Generate Speech function requires several input parameters. We need the text you want to convert. We also need a voice URL for the audio sample. The language code is another required field. Finally, we include exaggeration and weight settings. Next, we need to define what our function will return. We should specify the types for the output data. The output will include a success status. This is a simple true or false value. We also return the S3 key. This is the unique address for your audio file in AWS storage. You will get the full audio URL as well. This makes it easy to access your generated speech. We provide the project ID from our database. If any error occurs, we return a clear error message. Next, we need to add the URL for our S3 bucket. We need to retrieve the URL for our S3 bucket from AWS. We will then store this URL inside a variable. You can easily get that by going to your AWS console. Find one of your previously generated audio files in your S3 bucket. You can simply copy the full URL of that audio file, then paste that URL into a new tab in the browser. Copy the first portion of the URL from your S3 bucket. You can then paste it directly into this variable. Make sure you remove that trailing slash at the end. We have successfully saved the S3 bucket URL in our variable. This step is now complete, and we can proceed. Now we will create our main function called Generate Speech. This function will take the input data we just defined. First, we will add a try and catch statement. This will help us catch any errors that occur. First, we check for any errors during the process. If an error occurs, we log it to the console. We label this error as a speech generation error. We also return a status of false to the user. We send back an internal server error message. Inside the try block, we first retrieve the user's session. We use the getSession method from Better Auth for this. We should first check if a user session exists. If no session is found, we return an operation failure. We also send an unauthorized error message. We need to check if the user's input has all the required fields. This includes the text, the voice S3 key, and the language setting. If any of these are missing, we will return an error message. The error will state that some required fields were not provided. Next, we need to calculate how many credits are required to generate this speech. We calculate the cost for generating speech based on character count. Every 100 characters will use 1 credit from your account. We charge 1 credit for the first 100 characters. For every additional 100 characters, we charge another credit. For 100 characters, we charge 1 credit. For 200 characters, we charge 2 credits. We determine the required credits using a specific formula. This calculation ensures we charge fairly based on text length. Now we need to verify the user has sufficient credits to continue. If they do, we can proceed with generating the speech. If the user does not have enough credits, we will throw an error. This will prevent the process from continuing. Now, we need to check the user's current credit balance. First, we need to retrieve the user's current credit balance. We need to check if the user exists in the system. If we cannot find the user, we must throw an error. This error will state that the user not found. If we find a user record, we need to verify their available credit balance. If the user's credit balance is less than what is needed, we will return a failure. The error message will state there are insufficient credits. It will specify the required amount and the current amount available. If the user has enough credits, we can proceed with the next step. We need to make a request to our text-to-speech API. The URL for this API is stored securely in our environment variables. First, we need to import our environment variables. We send a POST request to this specific URL. We include the necessary headers in this request. We set up the headers with our model key and secret. We also prepare the body of the request to send the data. In the request body, we send several key pieces of data. We include the text you wish to convert into speech. We also send the selected voice sample file. The chosen language is included as well. We provide the exaggeration setting for the voice. Finally, we send the weight parameter for the audio. After making the API request, we check the response status. If the response is not okay, we return a failure. The error message will state that the speech generation failed. If the response is successful, we convert it to a JSON format. The response has already been saved for us if the API call is successful. The audio file has already been successfully saved. It is stored securely within our S3 bucket using a unique key. Next, we need to save this audio URL in our database. This will let us keep a permanent record of the generated file. We define a variable named audio URL. This variable combines the S3 bucket URL from earlier. It adds the specific S3 key we received. At this stage, we know the result is successful. We can safely deduct the required credits from the user's account. We update the user's credit balance in the database. We subtract the required amount of credits from their total. This deduction happens immediately after the successful speech generation. We are going to save this project in our database. We will use a new table called Audio Project. Looking at our Neon database schema reveals an Audio Projects table. This table is currently empty and waiting for our data. We will save the project with all its important details. This includes the original text and the final audio URL. We also save the S3 key and the language setting. The voice S3 key is stored as well. We record the exaggeration and weight parameters. Finally, we link the project to the user who created it. We must say which user created this audio project. This connection is crucial for later. We will use it to fetch and display the user's personal projects. We complete our try block by returning a success status. We also return the S3 key and the generated audio URL. Finally, we send back the project ID from the Neon database. Our generate speech action is now fully implemented and ready to use. Our next step is to create a new action. This action will be called getUserAudioProject. This function retrieves the user's audio project data. We will display this information on the Create page. We also plan to use this data later. It will be used in the dashboard and other project sections. We will start by adding a try and catch statement. This is similar to what we did before. If we encounter an error, we will log it to the console. We will also return a failure status. The error message will state we failed to fetch the audio projects. First, we attempt to retrieve the user's session. If we cannot find a valid session, we will return a failure status. The error message will indicate the user is unauthorized. We retrieve the user's audio projects using the Find Many method. We filter these projects by the current session user. We order the results by descending creation date. This means your most recent projects will appear at the top of the list. If everything goes well, we will return a success status. This action will return all of the user's audio projects successfully. We have now successfully created the Get User Audio Projects action. This function will fetch the user's audio projects from our database. It returns them sorted from newest to oldest. Next, we need to build two more actions. We will create one for uploading voice files. We also need another action to fetch the user's uploaded voices. Next, we will create a new file for voice uploads. We will place it inside the Actions folder. Let's name this new file voiceupload.tsx. We are creating a server action for this file. We must add the useServer directive at the top. The next step involves installing the AWS SDK package. We need this library to interact with Amazon's cloud services. To install the required package, we can search for the AWS SDK. We will find it on the npm package registry. You can install it using this specific command. Let's copy this installation command from the documentation. We'll paste it directly into our front-end terminal. The installation process should be complete now. Let us import the necessary components from the AWS SDK client. We are bringing in the S3 client, the put object command, and the get object command. We also need to import a function called getSignedURL. This function is essential for creating a pre-signed URL. We need to import auth and headers from Better Auth. We also need Next.js headers. These imports help us get the user session. They are essential for authenticating the user properly. We need to import environment variables, the database, and cache functionality. These imports are necessary to build our actions correctly. First thing first, we want to create the S3 client. We initialize a new S3 client from the AWS SDK. We define the region using our environment variable. We also configure the required credentials. These credentials include an access key ID and a secret access key. We retrieve all these values from our environment variables. Next, we should define the data structure for the voice upload result. This type will specify what information we get back. We want the result to include several key pieces of information. It should have a unique ID for the voice. It also needs the S3 key and the final URL. Finally, it should return any potential error messages. Let's dive in and create our upload voice function now. We are going to create our function called upload voice. This function will receive the form data as its input parameter. It is designed to return the upload voice result as its output. Inside this function, we will add a try and catch statement. Inside the catch block, we log the error to the console. We then return a success status of false. The accompanying error message will be failed to upload voice file. First, inside our try block, we need to get the user's session. We must first check if a session exists. If there is no session, we will return a failure status. We will also return an unauthorized message. We also need to check for the AWS access key. We must verify the secret access key. We should also confirm the S3 bucket name. We need to verify that all of our AWS S3 credentials are properly set. If any one of these required credentials is missing, we cannot proceed. In that case, we must return a success status of false. We will also send back an error stating that AWS S3 is not configured. If the credentials are valid, we can proceed to retrieve the file from the form data. We will extract the file from the form data. We then save it into a variable we are calling file. First, we check if a file was actually uploaded. If no file is found, we return a failure status. We also send back an error message stating that no file was provided. We also need to check the file type. The uploaded file must be an audio file. We should also verify the file's overall size. We need to ensure the file size does not exceed 10 megabytes. This limit is important for our system's performance. Now that we have verified the file is acceptable, we need to identify its format. We will extract the file extension from its name. We take the original file name and split it at each period. We then take the very last segment to determine the file extension. Next, we need to define what our file name will be. We want to save this file inside the Voices folder in our S3 bucket. We are going to specify the folder path as voices/. We will create a dedicated folder using the user's unique identifier. We will create a separate folder for each user. This folder will be named using their unique user ID. We will construct a unique file name using the file extension. We also include the exact date and time of the upload. This ensures each file has a completely unique identifier. The name is generated using the current date and time. We are now ready to upload this file to our database. We will now use the send method from the S3 client. We send the file to our AWS S3 bucket for storage. This action requires the bucket name we set up earlier. It also uses the unique file key we defined for the voice. Once we upload the file successfully, the next step is to generate a signed URL. We create a signed URL using the getSignedURL function. This URL will remain valid for 7 days before it expires. We then save this signed URL directly into our Neon database. This creates a permanent record of the voice file location. We will now save the voice information to our uploaded voices table. We will create a new entry in the database. We will pass the voice name, its S3 key, and the generated URL. We also save the user who uploaded this voice file. After everything is saved successfully, we return a success status. We successfully saved the uploaded voice data to the database. The function then returns the new voice ID, its S3 key, and the signed URL. We have successfully created the upload voice function and action. This action allows users to upload their own custom voice files. Now, let's create the next action. This one will fetch the voices that a user has uploaded. Next, we will create the function to fetch the user's uploaded voices. First, we will use a try and catch block to handle errors. Inside the catch block, we will log the error to the console. We also need to return a success status of false. The error message will be failed to fetch uploaded voices. Finally, we return an empty array for the voices. Inside the try block, we first check for an active user session. If no session is found, we return an unauthorized error. We also make sure to return an empty array for the voices. If the user's session is valid, we can proceed to fetch their uploaded voice files. We will retrieve all the user's voices from the database table. We will use the find many method for this query. We will query the uploaded voices table in our Neon database. We will use the find many method to fetch all the user's voices. We will sort the results in descending order. It looks like the module installation did not complete correctly. Let's copy that package name. We will install it again in our frontend. Let's run the installation command to install this package. The installation has completed successfully. We are no longer seeing any errors in our code. We have now completed building all the necessary backend actions. These actions are essential for powering our create page within the dashboard. Next, we should define the types our application will use. To keep our code organized, we should create a new folder now. Next, we will create a new folder named Types. This folder will be placed inside the src directory. We will also create a new file inside it called TTS. In this file, we will define all the type definitions. These types are specifically for the text-to-speech features in our application. Our first type definition is for the generated audio. This generated audio object will contain several important properties. It includes the S3 key and the full audio URL. It also stores the original text and the selected language. Finally, it records a timestamp for the creation date. Next, we define the voice file type. This type includes a name property. It also contains an S3 key property. Next, we define the uploaded voice type. It includes an ID, a name, and an S3 key. It also contains the URL and the user's ID. We track when it was created and updated. Finally, we have the language type. It contains a code, a name, and a flag. Let's move on to building the create page for our application. Let's examine the project structure in the diagram. We will create a new folder named create inside our dashboard directory. Inside that new folder, we will add a file called page.tsx. Let's go ahead and create that page in our application now. We will navigate to the dashboard directory in our project structure. Inside the dashboard, we will create a new folder named create. Within this new create folder, we will add a file called page.tsx. Let's start by creating a basic React functional component. Let's name this component the create page. We mark this file as a client component. We add the use client directive at the very top. We need to import redirect and sign-in components from Better Auth UI. This allows us to handle user authentication and verify the user's login status. We will import a loading spinner icon from Lucid React. This icon will display during page load. We need to authorize the user on the client side. We will import the auth client from Better Auth for this purpose. We need to import 3 essential React hooks for our page. These hooks are useEffect, useState, and useRef. We also need to import a tool called useRouter from Next.js navigation. This will let us programmatically send users to different pages. Let's import the actions we created in the TTS file. We need the generate speech function for creating audio. We also need the function for getting user audio projects. We need to rename the generate speech function. We will call it generate speech action instead. This naming change makes its purpose much clearer. It also prevents any potential naming conflicts in our code. We will bring in the upload voice function. We also need the action for fetching the user's uploaded voices. We also want to import the toast function from Sonar. This will allow us to show notification pop-ups on the page. We should also import the custom types we defined for our text-to-speech features. These types include the generated audio, voice file, language, and uploaded voice. Let's define our languages array. It will contain all the languages available for use in the application. We will use this language type to define our languages. Each language object has a code and a name. It also includes a flag icon. You can find this complete language list in our GitHub repository. You are welcome to copy and paste it from there. Next, we will add the sample voices from our S3 bucket. These are the preloaded voice options for our users. You might remember we created a samples folder in our S3 bucket. Inside that samples folder, we added another one called voices. We uploaded a sample voice file named Michael into that location. Any voice file you upload to this samples folder becomes available for all users to select. Our first step is to initialize the router for this page. We will use the useRouter function from Next.js. This function provides the ability to redirect users. It also allows us to refresh the page data. Next, we will create a state variable for loading. This variable will start with a true value. This page starts with a loading state. We show this loading indicator first. Once we successfully fetch the data, the main content will appear. We need to track when the generation process starts. We will create a state variable called isGenerating for this purpose. When you click the Generate Speech button, you will see a loading indicator appear. This shows that the system is processing your request. The next things we want to have is for the uploading the voices to AWS. We are going to create a state variable for the loading effect. This state will control the loading animation. This piece of state starts with a value of false. We need a state variable to hold the text from the input. This state will track any changes the user makes to the text. We are adding a piece of state named text. Its starting value will be an empty string. We need a state variable to track the selected language. Its starting value will be set to English. This piece of state controls the language selection menu. It determines which language option is currently active. When you select a language from the menu, it becomes the active choice. This selection then controls the speech output. Now, we need to set up the state for the selected voice. This will control which voice is used for the speech generation. For the starting value, I will select the voice called Michael. We now set up 2 controls for exaggeration and weight. The initial value for each control is set to 0.5. Next, we need to handle the generated audio files. These are the audio clips that will be displayed for the user. We need to fetch all the audio files you see displayed here. We will store these audio files in our application state. This state is called generated audios. We'll start with an empty array as the initial value. Next, we need to track which audio file is currently playing. This piece of state will store the active audio. When you click the play button on any audio file, it will be played back in this dedicated audio player section. We need to create a state variable to hold the currently playing audio file. This will allow us to manage which audio is active. We will set the starting value for this state variable to null. We need a state variable to store the user's uploaded voices. This will populate the selection menu you can see on the screen. Next, we need to create a useRef hook for the audio reference. This will manage the audio element in our component. This creates a reference for the audio player component. The initial value for this reference is set to null. Next, we are going to create a new function. This function will be responsible for fetching the user's uploaded voices. We call the action we created earlier, getUserUploadedVoices. If the result is successful and the success flag is true, we set the user uploaded voices to these results. We will use the useEffect React hook to initialize the page data. This hook runs once when the page first loads. We add a React hook called useEffect. This hook will call our initialization function named initializeData. This function runs asynchronously. It will be executed a single time. This happens when the page first loads. The very first time this page loads, we need to set up all this data. We will implement error handling for this function. We will use a try and catch statement. Inside the catch block, we will log the error to the console. This helps us see what went wrong. We need to handle any errors that occur. We will also set the loading state to false. We started by setting the loading state to true at the beginning. This means the page begins in a loading condition. If we encounter a problem while initializing the data, we must set the loading state to false. Inside our try block, we will fetch 3 separate pieces of data simultaneously. We need to retrieve the user's current session. We also need to fetch their previously saved audio projects. Additionally, we must get the collection of voices they have uploaded themselves. We check if both results for the audio projects are successful. We then map through each project in the results. We set the projects inside the generated audio state. These generated audio files will be displayed right here in our application. You will see them appear in this section of the website. Next, we need to verify that the voice data was fetched successfully. We will check if the voice result indicates a success status. We then set the user uploaded voices state. We assign it the voices array from our successful result. Once we have successfully retrieved all the necessary data, we can update the loading state. We will set the isLoading variable to false at this point. Next, we need to create our main function. This function will handle the speech generation process. Our first step is to add a conditional check. First, we need to check if the user has entered any text. If the text field is empty, we will display an error message. This message will ask the user to please enter some text. After showing the error, we will exit the function immediately. Next, we will set the isGenerating state to true. Then, we will wrap our code in a try and catch block. Inside the catch block, we will log the error to the console. We will also display a toast notification with the error message. We should also add a finally block to this code. This ensures that our generating state is properly reset. It will run whether the operation succeeds or fails. We will set the generating state to false. This happens whether the process finishes successfully or if an error occurs. Inside the try block, we call our generate speech action. We save the successful result into a variable here. We need to check the result we get back. We want to verify the operation was successful. We must confirm there is an audio URL available. We also need to check for an S3 key. If any of these checks fail, we must throw an error. After we confirm the results are successful, we use the router's refresh method. This action updates the page with the new data. This command tells the application to refetch the current page's data. It will then re-render the page with the new information. This all happens without a full browser reload. We will now store the newly created audio file. We save it inside an object named new audio. We save the new audio object into our current audio state. We also need to add this new audio to our generated audios list. To automatically play the new audio after generation, we will use a timeout method. We first check if the current audio file exists. If it does, we instruct the audio player to load it. If any error occurs during this process, we will catch that error. We then display a helpful error message to the user. We introduce a brief delay of 100 milliseconds before playing the audio. This ensures the audio file is fully loaded and ready for playback. If the entire process completes without any issues, we will display a success notification to the user. Next, we will build a function to handle audio playback. This function will allow users to play their generated speech files. This function will be called play audio. We begin by setting the current audio to the input audio file. We then use the same setTimeout method from our earlier implementation. We want to play the selected audio file immediately. We will also show a small pop-up notification. This notification will inform you that playback has started. Next, let's build a function for downloading the audio. This function will open the audio in a new browser tab. Your browser will then automatically start the download process. A success message will confirm that your download has begun. Next, we will create a function that handles uploading a voice file. This function will send the voice data to Amazon Web Services. First, we need to get the file from the event object. We access the file's property to get the list. We only want a single file from the user. Therefore, we select the first item in the list. If no file was selected, we simply exit the function. We must also verify the file type is an audio format. If it is not an audio file, we will show an error message. The message will ask the user to please select an audio file. We need to ensure the audio file is not too large. Let's verify its size is within our acceptable limits. We need to check the file size before proceeding. If the file is larger than 10 megabytes, we must show an error. The file size must be less than 10 megabytes to be accepted. Once we confirm all the conditions are met, we will set the uploading state to true. Next, we will implement error handling for this process. We will wrap our upload logic inside a try and catch statement. This ensures we can properly manage any errors that might occur. First, we want to throw an error inside the catch block. If everything is okay in the finally block, we set the state. We also set the state if an error occurs. We want to set the is uploading voice state to false. Inside the try block, we create a new form data object. Then we append the selected file into this form data object. This try and catch block must be placed inside the function. This placement allows us to access the file we selected earlier. We will now call the upload voice function we created earlier. We pass the file to this function. The result from this operation is saved in a variable. If the upload was not successful, we need to throw an error. This error should state that the upload process has failed. If the upload is successful, we want to display a success message. This message will confirm that the voice file was uploaded successfully. Once the voice upload finishes successfully, we need to refresh the list of available voices. We will call the function to fetch the user's uploaded voices again. We have now completed writing all of our necessary functions. This marks a significant step forward in our application development. First, we check if the page is in a loading state. If the loading state is true, we return a loading indicator. This loading indicator uses the loader component from Lucid React. If the data is still loading, we will display a loading indicator. Otherwise, we begin by returning an empty fragment. First, we check if the user is logged in. If they are not authenticated, we redirect them to the sign-in page. We will place all of our page content inside the sign-in wrapper. This ensures the user is properly authenticated. We start by adding the main title to the page. We use an H1 tag for the heading. It will say text-to-speech generator. Then we add a descriptive paragraph below it. Let us check how our website looks with this title in place. You can see the title displayed correctly at the top of our page. Let's build the settings panel for our application. You can see this area on the left side of the final version. Notice the text-to-speech section on the right is twice as wide. It occupies 2/3 of the available space. The text-to-speech area on the right is twice as wide. It takes up 2/3 of the available space. We can achieve this layout by adding 2 separate sections to our application. These sections will divide the page into distinct areas. Now we need to add the main content area to the page. We will place this section right after the heading. It should go just before the signed-in closing tag. This main content div will serve as a container. It will center all of the elements horizontally on the page. This creates a balanced and visually appealing layout. Next, we will set up a grid system to organize our layout. The left-hand section will take up 1/3 of the total width. We will assign the left side a column span of 1. This gives it a specific width within our layout. We will now add the settings section to the left-hand column. This section will contain all of our configuration options. We will create a separate component specifically for the settings section. This approach helps us keep our code organized and modular. Next, we will organize our project structure better. We will create a new folder specifically for Create Page Components. This new folder will be named Create. Next, we will create a React functional component. We will build this component for our speech settings. We are going to name this component Speech Settings. We need to make this a client-side component. Let's import some icons from the Lucid React library. We will be using them for our interactive buttons. We also need to import 2 components from ShadCN UI called Card and Card Content. We need to install these card components into our project as well. We navigate back to the ShadCN UI documentation. We need to install the card component from there. Let me first check our components folder. I want to see if we already have the card component installed. It appears the card component has not been installed yet. Let us return to the ShadCN UI documentation. Navigate to the card component section. You can copy this specific npm installation command. Paste the copied command directly into your terminal. The installation is now complete. We can see the card component available in our user interface folder. It is located inside the components directory. Let's also import the button components from the ShadCN UI library. We need to import our custom types from the types folder. We need to import several values for our component. These values include the languages list and the voice files. We also need the selected language and other related data. We must define their types using a specific variable. This variable is the speech setting props interface. This step involves creating a variable for the types. We will define an interface named speech setting props. This interface will list all the necessary variables. For example, the languages variable is an array of options. The voice file is also an array. We have defined all the other variables here as well. You can see we have some functions here, like ungenerate. We defined this function earlier. It returns a promise with a void response. Inside the speech settings function, we first define the credits needed. We need to display this value right before the button. We want to show the user exactly how many credits are needed. This calculation is based on the text they are currently typing. We will calculate the credits based on the text length. Every 100 characters will cost 1 credit. Next, we will wrap our application interface. We will use card components from the ShadCN library. These are the card and card content elements. At the top of the page, we will add a title. This title will say, "Customize your speech." Let me demonstrate how this component looks within our actual application. Let us refresh our application page now. The component is not yet visible on our page. We need to add it first to see the changes. Let's move our application preview over to the right side. We will position our code editor on the left. This setup lets us watch the changes happen in real time. Let's navigate back to the Create page. We will add the speech setting component inside the main content area. We must import the component we have already built. We also need to pass all of this information as a property. You can now see our new component displayed on the website. It shows the two main titles we just added. Let us continue building our speech settings component. You can see our updates happening live on the right. Now we will add a main container here. Inside that main container, we are going to place another inner container. Next, we create a label for the language setting. We will place a globe icon right before the word language. Next to the language label, we add a drop-down selector. This selector will loop through all our predefined languages. For each language, it will display the national flag. It will also show the language name next to the flag. Now if you click on this language selector, you will see all the available languages predefined earlier. When I click on Italian, the selection changes. This triggers the setSelectedLanguage function. The function will then apply that specific language. Now that we have the language selector in place, we will follow a very similar process for the voice selection. We will now add a label for the voice selection. This label will feature a volume icon. Following the label, we include a drop-down selector. This selector will list all the voices you have previously uploaded. You can then choose any voice from this list. Currently, our voice selector only displays a single voice option. This is because we have only uploaded one voice file so far. The voice selector will update automatically. You will see any new voices appear in the list. Now we are going to implement the upload feature for new voices. Next, we have a label that clearly states upload your voice. This label is accompanied by an upload icon for visual clarity. Next, we need to set up a conditional statement. This means we will check for a specific condition. We will check if a file is currently uploading. If it is, we will display our loading indicator. Otherwise, we will display a file selection field. You can use this to pick a file directly from your computer. The system will then upload the file you have chosen. We also include some helpful text here. This text explains the supported file formats for the voice upload. It provides all the necessary details for the user. Let us test the upload functionality we just created. Let us choose a file to upload. We can select any audio file from our computer. Let me select a voice file as an example. I'll choose the Julian voice file for this demonstration. The upload process begins now. Your voice file will be sent to AWS. You can observe the loading effect we designed earlier. Now if you check the voice selector, you will see the new voice appears in the list. If you check our AWS console and navigate to the Voices section, you will see a new voice has been added there. This folder is named with the user's unique ID. It organizes all of their uploaded voices. Let's verify this in our Neon database. Let's look at the user table in our Neon database. You can see the user ID right here. This user ID matches the ID we saw in the AWS folder. Inside this folder, we can see the uploaded voice file. We can also verify this in our database. Navigate to the Uploaded Voices section in Neon. You can see the new voice has been added successfully. The name Julian is now displayed in the database. Our upload process is functioning correctly. The voice file has been successfully saved to our storage. The database has also been updated with the new entry. Let's continue building out the rest of our application features. Next, we will implement the exaggeration setting. This control adjusts the emotional intensity of the speech. We add a settings icon first. Next, we give this section the title, Emotion Intensity. This title clearly describes the setting. We will allow users to adjust this value along a sliding scale. The scale ranges from 0 to 1. The starting position for this control is set at 0.5. We have a range input for this control. The minimum value you can set is 0. The maximum value available is 1. You can adjust this in precise increments of 0.1. Every time you move the slider, it updates the state variable for exaggeration. The value changes directly as you interact with the input. This input uses a range-type slider. Following the exaggeration slider, we will now implement the weight input control. This will function very similarly to the previous setting. The weight input functions in a very similar way. It uses the same type of range control. We use the same settings icon for this control. The title for this section is Pacing Control. We add another range input with identical settings. Adjusting this slider will update the weight state variable. Next, we will add the credits display that shows the cost. We will also add the main Generate Speech button. Next, we will add a new container element. This div will hold our credits display and the Generate button. First, we need to set up a conditional statement. We need to calculate the cost for the text. This cost is determined by the number of credits required. We need to display the cost for creating the speech. This cost is shown as the number of credits needed. We also have a conditional statement to handle the text. We check if the user needs more than one credit. If they do, we add an S to the word credit. Otherwise, we just use the word credit. We will also display the total number of characters in the text. This shows the user the current length of their input. Next, we need to add a button for the user. This button will go right after the credit condition. This button will be disabled during speech generation. It will also be inactive if the text field is empty. We want to display a loading indicator while the speech is being generated. This loader will appear inside the button itself. The button will display the text, Generate Speech. It will also include a settings icon. Clicking this button will activate the function to generate the speech. We have now successfully completed the speech settings component. This component allows users to customize their audio output with various options. Our next task is to build the text box component. This is where the user will type their text. The component will also feature the currently playing audio. Let's proceed by creating a new component. We will place this component inside the Create folder. Let's name this component Text Input. This component will be a client-side component. We need this because it will handle interactions directly on the web page. We will import several useful icons from the Lucid React icon library. Next, we will import the card and card content components. These come from the ShadC NUI library. We also need to import the button component. We also need to import the generated audio type. We will get this type from our TTS types file. We created this file earlier. Let's define the properties for our text input component. We need to specify what data it will receive. Our function will receive several values as input. One of these important values is the text itself. It needs the setText function to update the input. It also requires the current file state and the audio reference. Additionally, it needs the onDownload handler for saving files. We will now add these properties as parameters to our function. This allows our component to receive and use these values. Let's start by wrapping our entire component with the card component. This will give our application a nice, structured container. We will place our content inside the card content component. Let's start by adding a title at the top of this component. Now we will add this text input component to our create page. We want to place it right after the speech settings component. Next, we want to put this component inside a div element. Let's import the text input component we just created. Then we will pass the necessary props to it. Let us check our application now. We should see the component titles appearing inside the create page. Let's continue building our text input component. After the title section at the top, we will add a container. Inside that container, we will place a text area element. We will set a maximum length for the text area. It will be limited to 500 characters. This text area will have 8 rows for your text. Any change you make inside it will trigger the setText function. This function updates the text state variable. You should now see the text area appear in our application. It has a placeholder text with instructions. We will now add a new section directly below the text area. This area will display a live count of the remaining characters. We add a span element to display the current character count. This shows the number of characters used out of the maximum allowed 500. You can see the character count displayed directly below the text area. As you begin typing into the field, you will notice the character count updating in real time. This number shows exactly how many characters you have remaining. You are limited to a maximum of 500 characters. Another important thing happens while you type. The character count in the settings component updates automatically. It shows the exact same number of characters you have entered. This number is then used to calculate the required credits. It also determines the final cost for your text. Next, we will add a conditional statement. If the user has typed any text, we will display a button. This button will contain an X icon and the word clear. Clicking this button will clear all the text from the input field. It resets the text area to be completely empty. You can see the clear button appear when text is present. Clicking this button will completely erase the input field. Now let's add a section to display the audio we just generated. Next, we need to add a conditional check. We check if there is a current audio file available. We only want to display this container when that value is true. Inside this section, we will add a heading that says Latest Generation. This label will clearly identify the newly created audio file. We also want to include a download button for the audio file. This allows you to save the latest generation to your device. We want to let the user download this audio file. This download button will appear when an audio is available. This button will have the word download as its label. It will also include a download icon for visual clarity. We also need to display the audio file's name for the user. If the audio has associated text, we will show that as well. We want to give users the ability to play back their generated audio. This lets them listen to the sound file directly. Next, we will add an audio player element. This audio player will use the audio reference we created. It will include playback controls for the user. These controls allow you to play and pause the audio. The player will stretch to the full width of its container. The audio source will be set to the current audio file. We have successfully completed building the text input component. It is now fully functional and ready for use. Currently, we cannot see any generated audio file here. This happens because we have not created any audio yet. The section will populate once we generate our first speech. Now we are going to add the final section to this page. This part will display the user's recent audio generations. The next logical step involves displaying the user's audio generations. We will place this section at the bottom of the page. Let's create a new component for this. We can name this file Audio History. This component will also run on the client side. It requires this setup to handle user interactions. Let's bring in icons from Lucid React. We also need the button component from ShadCN UI. We also need to import two specific types from our type definitions. These are the generated audio type and the language type. We previously created these in the TTS type file. We need to define the types for our audio history component props. These props include the generated audios array. They also include the available languages. The props include an on-play and on-download functions. We will now pass these props as parameters to our function. This allows our component to receive and use the necessary data. Now, we need to work within the return statement. We will add a main container element first. Then, we will place a secondary container inside that first one. This container will set a maximum width for the display. We start by adding a title for this component. This title will be placed at the top of the container. Let's add this component to the Create page. This will allow us to see the changes we have made. Let's navigate back to our Create page component now. Let's import the audio history component we just created. We will place it at the very bottom of our page. We must pass the necessary properties to the audio history component. These props are essential for the component to function correctly. Let us return to the audio history component. We can continue building the page with it. We will also test and verify the changes on our live website. You can now see the recent generation section at the bottom of the page. It displays the title, Your Speech Generation Histories as well. Now, we will add a conditional check right after this heading. This condition will determine what content gets displayed to the user. We check if any generated audio files exist. If there are files, we will display them for the user. If there are no generated audio files, we will display a message. This message will tell the user to create their first audio. You are seeing an error message on the screen right now. We can fix this issue by adding an empty fragment component. This will prevent the error from showing up. You can see that our application is now running without any errors. Let us verify that we have placed all the components correctly. You need to make sure you close that curly brace right here. If we have any generated audio files, we can display them on the screen. This will be the first part of our conditional statement. First, we will add a container for our grid layout. This will help organize the audio files neatly. For extra large screens, the grid will display 4 columns. For large screens, we have 3 columns. For small screens and above, we display 2 columns. When viewed on a mobile device, the layout will automatically adjust. It will display just a single column for a better user experience. Next, we will loop through all the generated audio files. We want to display each audio file individually inside this container. Let's replace this empty fragment with a div container. This container needs a unique key for each item. We will set the key to the current index from our loop. Inside this container, we will display each generated audio file. First, we display a music icon. We get this icon from the Lucid React library. We can display the language for this audio file. The language information comes directly from the audio object. We also want to show the exact time of its creation. This is where we display the text content for each audio file. This displays the original text that was used to generate the audio file. Next, we need to create a new container. This div will hold our action buttons. We will add a button inside this container. This button will allow users to play the generated audio file. Following that, we will add a download button for the audio file. This button allows users to save the generated audio to their device. That completes the audio history component. We have successfully built it with all its features. Let's run our application now to see how the audio history component looks. At this point, we have not generated any audio files yet. Our history section is currently empty. You can see the message indicating no generations yet. Let's type a short sentence into the text area. Then we can press the Generate Speech button. Once you have entered your text, simply press the Generate Speech button. This generation will cost just 1 credit. The cost is low because the text only contains 18 characters. We have encountered an error at this point. Our application is showing an internal server error message. Let's take a look at our Modal GPU service to see what happened. Looking at the status, the generation process actually completed successfully. The file was generated successfully on the backend. We can confirm the process completed without any issues. Let's navigate to our AWS console to check the file storage. You can see the file has been successfully saved. It is now stored inside our AWS storage as well. Everything appears to be working correctly on our application side. However, if we check the database in our Neon project, we notice a problem. Refreshing the data reveals that the new file has not been added to this table. Let's check the console for the error message. It appeared when we were creating the audio project. We are encountering an error message. The error states that the S3 key is missing. Let's check what's happening on the backend server. If you recall, the response from our backend included an S3 key. This key used a capital letter K in its property name. Looking at our function, we are using the lowercase version instead. Let's navigate back to the tts.ts action file. We are going to find the generate speech function. When the response comes back from the model URL, we receive a specific data structure. The key we are looking for should be capitalized. We need to fix this issue with the all places with S3 key. Let's attempt the generation process once more to verify our fix. This time, the text-to-speech generation completed successfully. We can see the new audio file in our list. You can now see our first generation in the recent generation section. The audio player appears in this section as well. You can play back the generated audio file directly. You also have the option to download the audio file. When you click the download button, your audio file will be saved directly to your browser. We should also verify the data in our Neon database. Let us refresh the table to see the new entry. The database now contains a new audio file entry. This entry includes the text that was converted to speech. It also contains the URL pointing to the generated audio file. The S3 key acts as the unique address. It points to the file stored in our AWS cloud storage. The audio file is set to use English as its language. This is correctly recorded in our database. This information confirms the database contains all the required data fields. We can verify the sample file used is michael.wave. We can also see the exaggeration weight setting is stored correctly. The entry includes the user ID for reference. The timestamps for creation and updates are also recorded properly. All the data is now correctly stored in the database table. You can see every piece of information is present and accounted for. We have successfully finished building the Create page inside our dashboard. This component is now fully functional and ready for use. Let's go ahead and commit all our changes to the Git repository. I have created a commit message for completing the dashboard Create page. We can now commit our changes and push them to GitHub. That wraps up our work on the Create page. In our next session, we will begin developing the Projects tab. That wraps up our work on the Create page. We will continue with the Projects tab in the next section. In our previous section, we successfully finished building the Create page. In this section, we will build the Projects page. This is where users can view all of their created audio files. Looking at our final application, you can see a problem. The Projects page currently shows a 404 error. This happens because we have not built this section yet. Let us return to Visual Studio Code. Navigate into the dashboard directory. Create a new folder there named Projects. We will now create a new file inside that folder. This file will be named page.tsx. Let's start by creating a React functional component. We can use the RFC snippet to generate the basic structure quickly. Since this page includes interactive features, we must make it a client component. This change allows us to use React hooks and manage state. Next, we must import two functions from Better Auth UI. We need the redirect to sign-in function. We also need the signed-in function. This will check if the user is authenticated. If they are not logged in, they are sent to the sign-in page. Next, we need to bring in some icons for our design. We will get these from the Lucid React library. We need to authenticate the user on the client side. For this task, we will import the auth client from Better Auth. We need to bring in two important React hooks for our project. These are the useState and useEffect hooks. They will help us manage state and handle side effects. We are also going to import a couple of actions we built earlier. These actions are for fetching user audio projects and for deleting them. Currently, we are getting an error about the delete audio project module. It states the module does not exist inside the TTS file. Let me look inside the TTS file to find the issue. We have not actually created that delete action yet. We should create this function right now. This will be an asynchronous function, accepting a project ID. We start by adding a try and catch statement. Inside the catch block, we will log the error to the console. We also need to return that the operation was not successful. The returned error should say it failed to delete the audio project. First, inside our try block, we need to verify the user session. We first check for an active user session. If no session is found, the user is not authenticated. We then return a failure status with an unauthorized error message. Our next step involves verifying the project's existence. We need to ensure the project is actually present. We need to locate the specific project using its unique identifier. We will employ the findUnique method for this search. We need to check if the project exists. We also verify the project's user ID matches the session user ID. We will return a message indicating the project was not found. Alternatively, we will state the user is unauthorized. We will remove the project from our database using the delete method. This action permanently erases the project data. When all the operations complete without any issues, we will return a success status of true. We have successfully created the delete audio project action. This function is now ready to handle removing projects from the database. With the delete action now properly implemented, we can move forward. Let us continue building our projects page. We need to import card and card content components. These components help us create card elements for our page. Now we will also import two important components. We need the button and input components from our UI library. we need to use the router from Next.js navigation. This router allows us to redirect users between pages. It also helps refresh data when new information is available. Let's start by defining the type for our audio project. We will create an interface called audio project to establish the structure. We need to define specific types for each of these variables. This ensures our code knows exactly what kind of data to expect. We need to define a type for sorting our projects. This sort type can be by newest, oldest, or name. Looking at the final application, you will notice a drop-down menu. This menu allows you to sort your projects. You can organize them by newest, oldest, or by name. After we define the type, we need to create a state for loading inside the project's function. We set the initial value of this state to true. When the page first loads, we see a loading effect appear immediately. This loading state gives us feedback while the data is being fetched. Once the data retrieval is complete, the actual content will be displayed. We need to create a state variable for our audio projects. This state will start as an empty array to hold the data. We want to keep a separate list for the filtered projects. We will create a state variable for this purpose. Its starting value will be an empty array. We want to monitor what the user types for searching. This search query is important for filtering the projects, so we can create a state variable to manage our search query. This state starts as an empty string. Next, we create another piece of state to track the sort order. We set its default value to newest. We will initialize a variable called router using the useRouter function. This router variable helps us navigate between pages. It also allows us to refresh the data when needed. After that, we will use the useEffectReact hook. This hook will initialize the project's data when the page loads. Inside the try block, we will fetch two important pieces of data. We need to get the user's current session. We also need to retrieve their audio projects using our special function. We are going to use the action we created earlier for this. When the data comes back successfully, we will update our main project state. We also need to update the filter project state. Both states will receive the exact same list of projects. We should log the possible error to the console for debugging. Afterward, we set the loading state to false. This action stops the loading spinner. This useEffect hook will run just one single time. It executes only when the page first loads. We define this behavior by including an empty dependency array. After this initial data loading effect, we will set up another useEffect hook. This second hook will run whenever our audio projects change. It also responds to updates in the search query or the sort setting. Whenever one of these variables updates, we need to resort and update our filtered list of projects. First, we create a variable named filtered. This variable will hold the result of filtering our audio projects. We will implement the switch statement to handle the sorting. This switch will evaluate the current sort by value. Each case will correspond to a different sorting method. For the newest sorting option, we will arrange the projects from most recent to oldest. This places your latest audio files right at the top. If the sort option is set to oldest, we sort the projects by their creation date. We arrange them from the oldest to the most recent. For the name option, we sort the list alphabetically by the project name. Finally, we update the filtered project state with this newly sorted list. Next, we need to create a function for deleting a project. This function will manage the removal of audio projects from our list. Before deleting any project, we should ask the user for confirmation. We want to display a prompt that asks if they are sure. If the user confirms the deletion, we will remove the project from our audio project state. We will also call the delete audio project action we created. This ensures the project is permanently removed from our database. Next, we will create a function to handle downloading a project. This function will let users save their audio files. This action opens the project in a new browser tab. The audio file will then download automatically. This action will open the audio file in a new browser tab. Most browsers will then automatically begin downloading the file for you. We will now check if the page is still loading. If it is, we will display a loading indicator. Now we are ready to display the user's projects. We will render them within this return statement. Let us start by opening a fragment. This fragment will be empty for now. First, we check if the user is not signed in. If they are not, we redirect them to the sign-in page. We will display the projects page for authenticated users using this component. Let's start by adding a container to structure our layout. Now, let's add a title for this specific section of the page. This section displays the title on the left side. It also includes a button on the right side. The button redirects users to the Create page. We need a container for these two sections. We will add a div element here. This div will separate the content into two distinct areas. We should apply Flexbox properties to it. We want to use justify between for alignment. This will push the sections to opposite sides. Let us start by creating a container for the left side elements. Let's add the main heading for this section. This heading will display the text, Your Audio Projects. Following this heading, we should add a descriptive paragraph. This paragraph will state the total number of audio projects. It will use the filter project's length. It will correctly display the word audio or audios. We will now add this descriptive paragraph. This paragraph will display the total count of your filtered projects. We want to use the word audio for a single project. For multiple projects, we will display the word audios. This makes the text grammatically correct. We will also display the total number of audio files you have. Let us check our website now. We can verify our code is working correctly. You can now see the title displayed correctly. The text below shows one audio file. This is because our user currently has only one project. Next, we will add the button labeled New Audio. We will now add a button with a plus icon. This button will redirect users to the dashboard Create page. Our next step involves adding a card component. This card will contain a search bar for finding projects. It will also include a drop-down menu for sorting the items. We will use the card component from ShadCN UI. This component helps us create the project cards. We will now add a card component to our layout. Inside this card, we will include a card content section. We will now add a container to hold our search elements. This container will separate the search bar from the drop-down menu. It will align them on opposite sides. On the left side, we will place the search bar. This search bar includes a search icon and a text input field. We will track every change you make in the input as you type. The setSearchQuery function will handle these updates automatically. Next, on the right side, we will add a selector drop-down. This selector will have three different sorting options. You can choose newest first or oldest first. The third option sorts by name from A to Z. We track any changes in this selector. We use the setSortBy function for this purpose. Let's move on to creating the main content area. This section will display all of the audio projects the user has created. Each project card displays the audio's text content. You can also see its creation date and language. The card includes controls to play the audio file. You can also download the audio or delete the project entirely. Next, we will map through each project in our filtered list. We need to display all of them in this main section. Now we will add a conditional statement to our code. This condition will check if there are any filtered projects to display. We check if there are no filtered projects remaining. If that is the case, we display a different message. If we have projects to display, we will show them here. I will add empty fragments to each of these sections. This step prevents any potential errors in our code. We will now close the curly braces for this conditional statement. First, if there are no projects found, we want to inform the user. They might need to adjust their search terms. Alternatively, they can create their very first audio project. Let's add a card component here to display this information. Inside the card, we will add a card content section. This section will hold the information for our empty state message. We need to inform the user about the results of their search. We also mention if your current search didn't match any of your audio projects. Try using a different search term to find what you're looking for. If the user has not entered any search terms, we should display a special button. This button will invite them to create their first audio project. When clicked, it will take the user directly to the creation page. We also want to include a clear search button for the user. This button will appear whenever a search query is active. This button will clear your current search query. It sets the search term back to an empty string. Now, we can display the user's audio projects on the page. We will now display our projects within this container. We accomplish this by mapping through each project in our filtered list. Now we need to display the projects to the user. We do this by mapping through the filtered projects array. This process will give us access to each individual project. We are going to add a card component for each project. This card must have a unique key attribute. We will use the project's ID for this key. This card will contain the card content component. This component holds all the information for each individual project. We will start by placing a music icon at the beginning. Next, we will add a container element. Inside this container, we will display the text content of the audio project. We display the project's text inside a paragraph element. Next, we will create a separate section for the project's timestamp and language. This new division will clearly display both pieces of information. First, we will display the timestamp for the project. We add a calendar icon to represent the date. Then we display the exact time the project was originally created. Next, we will display which language this audio project uses. We will add a music icon to represent the language. After the icon, we will display the project's language. Now, we need to add a new section on the right side. This section will be placed inside the card content. We add an audio player element. This allows users to listen to their audio files directly. We add a source element to the audio tag. This source element's address points to the project's audio file URL. Next, we add a button for downloading the audio file. This button will trigger the handle download function when clicked. Following the download button, we add a delete button. This button will call the handle delete function. This function allows users to permanently remove the audio project. We have successfully built our projects page with all its features. This component is now fully functional and ready for use. Let us now check the results on our website. As you can see, the page is now fully functional. It displays only the audio projects that we have personally created. You can see the text of your audio project. You can view the creation time and language. You can also play the audio directly from this page. You can also download the file for yourself. You have the option to delete the project entirely from here. For example, if you search for a project that does not exist, you will see a message that says, "No audio found." You can then clear your search to see all results. You can also sort your projects. Use the drop-down menu to organize them by date or name. We have successfully built our projects page. It now includes all the intended features and functionality. Let's commit our changes and push them to GitHub. Let's commit our changes to the local repository. After that, we will push these updates to our remote GitHub repository. Coming up next, we will build the main dashboard page. This will complete the core structure of our application. Welcome to this section of the tutorial. We will now finish building the dashboard page. Looking at the file structure diagram reveals a key detail. The dashboard page is built from a specific file. This file is named page.tsx inside the dashboard directory. This setup creates the /dashboard route for our application. Let's return to Visual Studio Code now. We need to navigate to the specific page file we just discussed. You can find it right here in our file structure. This page is a client-side component. We must add the useClient directive at the very top. We need to import two important functions from Better Auth. These functions are called redirect, toSignin, and signed-in. They will help us authenticate the user. They also check the user's current sign-in status. We also need to import several icons from Lucid React. This allows us to use them throughout our dashboard page. We must also import the auth client for user authentication. This handles the authentication process on the client side. We also need to import a couple of essential hooks from React. We will be importing the useEffect hook and the useState hook. We will now import the action we built earlier. This action fetches all audio projects for the current user. We will be also using some components from the ChadCN library. These components will help us build the card elements for this page. We need to import the button component from ChadCN. These buttons will be used throughout our dashboard page. We must also import useRouter from Next Navigation. This hook manages page redirects for our users. Next, we must define the type for our audio project data. We also need to import a type for user statistics. This type includes total audio projects and monthly counts. All these statistical values are defined as numbers. Inside our function, we start by adding a piece of state. We call this state is loading. Its purpose is to control a loading effect for the page. The initial value of this component will be set to true. The page will first display a loading indicator. After that, the actual data will appear. We create a state variable to hold audio projects. Its starting value is an empty array. Next, we set up a state variable to track user statistics. This state object will store various metrics about the user's activity. Initially, every numerical value within this object is set to 0. We also create a state variable for the user data. This variable will store the user's name and creation date. Its initial value is set to null. Next, we need to initialize the router. This will allow us to handle navigation within our application. We will now use the React useEffect hook. This hook allows us to run specific functions immediately after the page loads. We want to add a function called initializeDashboard. This function will be asynchronous. We will call it within this useEffect hook. We will now add a try-catch block to handle errors. Inside the catch block, we will log any errors to the console. We also need to add a finally block to our code. This block will run after the try and catch have finished. Inside this block, we will set the loading state to false. First, inside the try block, we retrieve all the necessary data. This includes the user's session information and the user's audio projects. First, we check if the user session is valid and we receive a response. We then assign the user data from the session result. If we also have the audio result and its projects, we update the audio project's state. Next, we create a variable named audios. This variable will hold all the data from the audio result. We then get the current date and save it as now. We also need to calculate the start date for this month. We perform a similar calculation for the current week. Finally, we use these calculated values to update the user statistics. We calculate the total number of audio projects. This value is set to the length of the audios array. We need to filter the audio projects for the current month. We will also apply a separate filter for the current week's data. We have successfully initialized all the dashboard data using the useEffect hook. This process loads the user's information and audio projects. Once the useEffect hook has finished running, we check the loading state. If the loading state is true, we display a loading indicator. Otherwise, we proceed to render the data we have successfully retrieved. First, we check if the user is not authenticated. If they are not, we redirect them to the sign-in page. Since the user is already authenticated, we can now display the dashboard content. Let's start by creating a main container element. This container will hold all the different sections of our dashboard. Looking at the final design, you will see a title at the top. This title greets the user by their name. Below that, we have a section for statistics. Next, you will find the Quick Actions card. This card contains several helpful buttons. Finally, at the bottom, we display the recent audio projects list. Let us begin by adding the header section. We will display a welcoming message that greets the user by name. This message will also provide a brief overview of their text-to-speech workspace. Next, we need to add a container for our statistics section. This container will hold all the cards displaying the user's data. Next, we need a container to display the user's statistics. Our first card will display the total number of audio projects. This data is pulled directly from the user stats object. Let's see how this appears in our running application. You can see the first card is now displayed. It shows the total number of audio files, which is currently 1. Our second card will display the data for the current month. This information is pulled directly from the user stats. You can see this second card in our application. We will also be adding some icons to these cards. These icons will help visually represent the data for each statistic. The third card displays data for the current week. This information is pulled directly from the user stats we calculated earlier. The final card displays user information. It specifically shows the member since date. This indicates how long the user has been with the service. This data comes directly from the user's information object. You can see it referenced right here in our code. Next, we want to add the Quick Actions card. This card contains several buttons. Each button navigates the user to a different page. Following the stats section, we will add a new card component. This card will contain a header section. Now we need to add a title to this section. Let's call it Quick Actions. Here is what the title looks like now. We will now add the main content area for this card. This section goes right after the header we just created. Now, we need to organize these buttons neatly. We will add a container to arrange them in a grid system. The first button will redirect the user to the Create page. This page is located within the Dashboard section of the application. You can see this button right here in our application interface. The next button allows you to view all your audio projects. The last button directs you to your account settings. You can manage your personal information there. Now, we will create a section for the recent audio projects. Let's proceed by adding this component to our page. Now we will add a new card component to the page. This card will display the recent audio projects. This card will have a header labeled Recent Audio Projects. If you have any audio files, a View All button will appear. This button will take you to the Dashboard Projects page. You can now see the title and button in our application. This appears right above the project list. Next, we will add the main content section for this card. Now we need to add a conditional check. This will determine what content we display inside the card. If there are no audio projects to display, we will show a message. This message will inform the user that no projects have been created yet. If we do have audio projects to show, we will display them here. Let us start by completing the first part of our conditional logic. Let us inform the user there are no audio projects yet. We will include a button for creating their first audio. Now we need to handle the case where we have content. Let me add the closing curly brace to resolve this error first. Next, we will add a container element to hold our list. Then, we will iterate through all of the user's audio projects. We are going to limit the display to just 5 projects. This keeps the recent projects list clean and manageable. We can use the slice method here. It will limit the display to just the first 5 projects. We use the map function to iterate over the array. This process gives us access to each individual audio project. For each project, we will create a container element. We need to give this div a unique key. We will use the audio ID for that key. First, we will display a music icon inside this section. This icon will represent the audio projects. Let us take a look at the application we are building. You can see the music icon right beside each project entry. This visual marker helps you quickly identify your audio files. Next, we display the actual text used to generate the audio. This is the original input provided by the user. We also display the language information for each audio project. Additionally, you can see the creation date for each project right here. This section displays the text that was used to generate the audio. You can also see the language of the audio file. The creation date is displayed right next to it. On the right side of the card, we will add a player. This will let you listen to the generated audio file. We add an audio player element to the page. This player is configured with the specific URL for the audio file. This allows users to listen to the generated audio directly. We now have a functional audio player directly on the page. You can click it to listen to your generated audio files. We have now finished building the dashboard page. It is fully functional and ready for use. Now let's commit our dashboard page changes to GitHub. We also will push this new feature to the repository. I have written the commit message as complete the dashboard page. Let's commit these changes to our local repository. After that, we will push the commit to the GitHub repository. In our next section, we will finish building the application. We will focus on creating the home page. Right now, our homepage does not have any content. That concludes our work on the dashboard. We will build the homepage in the next section. Let's begin building the homepage for our project now. First, we will create the navigation bar for our website. This nav bar will feature our logo on the left side. It will also include the main menu items for site navigation. On the right side, we will add two important buttons. These buttons are for signing in and trying the service for free. Let us return to our Visual Studio Code editor now. Now let's open the specific file that contains our homepage component. Our next step requires importing the button component. We will get this from the Chat CNUI library. Next, we will import the card component. We also need the card content component. These are essential for structuring our feature cards. We need to import some icons from the Lucid React library. We also need to import the link component from Next.js. This link component will be used for our menu items. It allows users to navigate between pages smoothly. The page will not refresh when they click a link. Next, we will create an array inside our homepage function. This array will help us organize our data. This array will contain all the features of our website. It is specifically for this section that displays the feature cards. These 4 cards will showcase the main features available on our website. They highlight everything our platform can do for users. Our first feature card will showcase voice cloning. This card will have a title that clearly states voice cloning. We will also include a pair of scissors icon for this feature. The next feature we will include is natural and expressive speech. Then we have support for multiple languages and diverse voice options. The final feature we are adding is lightning fast generation speed. We will loop through this array of features. This process will display each item in our application interface. Next, we will create an array for the testimonials section. This array will hold the customer reviews we want to display. Our application includes 3 customer testimonials. These testimonials showcase user experiences and feedback. Let's take a look at the first testimonial here. Here is our second testimonial for the application. We also have our third and final review here. Next, we will create an array for our pricing section. This array will hold all the features we plan to list. Now let's return a container component from our home function. This container will help structure our page layout effectively. This container sets the minimum height to fill the entire screen. It also features a slightly gray background. Let us test our application now. We will see how it looks in the browser. Next, we will create a container specifically for our navigation bar. This container will hold all the elements of our nav bar. Inside this container, we add another wrapper. This wrapper sets a maximum width for our content. We need a container that will distribute the items inside it. This is achieved using a justify between property. First, we will add the logo on the left side. The logo simply says AI Voice Studio. We will also place a sparkles icon right next to the name. Let's check our browser now. We can see the logo appearing in the application. Next, we will add the navigation menu to our website. This menu will help users move between different sections. Our menu contains 3 navigation items. These items link to different sections of our application. The sections are features, pricing, and reviews. Let's check the browser to see our menu in action. You can now see the menu clearly on the page. It is positioned on the right side. This is because we used the justify between property. Next, we are going to add the 2 call to action buttons. We will place them after our navigation menu. The first button allows you to sign into your account. The second button offers a free trial of the service. Our first section after the navigation bar is the hero section. This important area includes a main title and a descriptive paragraph. It also features 2 call to action buttons for user interaction. Finally, we will display some statistics about our service. Let's return to Visual Studio Code now. We will add this hero section right after the navbar component. Following the navigation bar, we will create a new section. This section will use a container to set a maximum width. Inside this container, we will add another container. This inner container holds our hero section. It features the text, powered by advanced AI. This text has a sparkles icon next to it. You can see this section in our application now. Now let's add the main title for our hero section. This title will clearly communicate the core purpose of our application. Next, we will add the main title for this section. The title will read Transform Text into Natural Speech. Notice that the natural speech text is displayed in a different color. This makes it stand out from the rest of the title. You can see the different color applied to natural speech. Following the title, we will add a descriptive paragraph. After that paragraph, we will include two separate buttons for the user. The first button invites users to try the service for free immediately. The second button lets them listen to a sample demonstration. Let us check how this appears in our application now. You can now see the two buttons clearly displayed on the page. The descriptive paragraph is also visible right above them. Our next step involves adding the stats section. This section will display key metrics about our service. The stats section displays key metrics about our service. We have a descriptive paragraph explaining these numbers. Then we show specific statistics like voices generated and active users. Let us check the results in our application. Our application is showing an error message at this point. Let's investigate what went wrong. The stats are now visible in our application. We can see the numbers for generated voices and active users. I seem to have missed a closing element in the structure here. The layout still appears to be functioning correctly for the time being. Let's move on to the next part of our homepage. This section is called Experience the Difference. Here, we will showcase actual audio samples generated by our text-to-speech model. This section requires user interaction with clickable buttons. I will create a separate component for this functionality. This new component must be a client-side component to handle the interactivity. The rest of our homepage will remain a server-side component. This separation is excellent for our website's search engine optimization. Now, we will create a new component for the demo section. Let's navigate back to our project in Visual Studio Code. Let's create a new component file named Demo Section. Let's create a new React functional component. We can use the RFC snippet to generate the basic structure quickly. This component needs to run on the client side. This requirement exists because it handles direct user interactions. We need to import the useState hook from React. This allows us to create state variables. We will use this state to manage our audio playback functionality. We also need to import the button component. This component comes from the shad CNUI library. We also need to import the card component. This card component will be used for displaying content sections. We also need to import several icons from the Lucid React library. These icons will be used throughout our user interface. We need to import the link component from Next.js. This allows us to redirect users to other pages. The page will update without a full refresh. We need to manage which audio sample is currently playing. We will create a state variable called playingID. This variable will start with a value of null. Next, we will create an array to hold our natural speech samples. This array will contain different voice examples for our demonstration section. I have created several sample audio files for demonstration. Each sample includes a unique identifier. They also contain sample text and a specific voice type. Finally, each has a corresponding audio URL for playback. We need to place these audio files inside the public folder. This is required for the application to access them correctly. I will create a new folder named Audio inside the public directory. This is where I will place all of our audio files. You can find all of these audio files in the GitHub repository. I am sharing the link with you for easy access. You can download these files directly from the GitHub repository. Alternatively, you can use your own audio files for this section. I am going to paste these audio files here now. You can see them on the screen. Next, we will create another array. This new array will be for the multilingual audio samples. I have included 4 example languages for you. These are Hindi, Spanish, French, and Japanese. You can always add many more languages later. This model supports an impressive range of languages. You can convert text to speech in up to 22 different languages. Let's create a function that will handle playing the audio files. We pass the ID and the audio URL into the function. This allows the system to identify and play the correct audio file. We check if the audio is already playing for this specific sample. If it is currently playing, we want to pause the audio. We also reset the audio playback to the beginning when we pause it. This creates a simple toggle play and pause action for the user. Next, we need to define our audio element. We'll create a new audio object using the ID we have. When audio is present, we will play that audio file. We then set the playing ID to the current ID. If we run into any errors while playing the audio, we will catch them. The application will then show an alert message. The message will inform the user that the audio cannot be played. When the audio finishes playing, we want to reset the playing ID to null. If any error occurs, we should also set the playing ID to null. Let's integrate this demo section component into our homepage. Next, we will add the interactive demo section to our homepage. Let us check our application to see the current progress. You can now see this new section appearing on the bottom of our page. Let's begin by adding the title for this demo section. Next, we will return a section element for our demo component. This section will contain all the audio demonstration features. Within this section, we will add a container element. This container will control the maximum width of our content. Next, we will add the main heading for this section. We will also include a descriptive paragraph underneath it. Let's take a look at our application now. We should see the title and description displayed correctly. Now we are ready to build the first section of our demo. This part will showcase the natural and expressive speech capabilities. Next, we will add a container for this section. Then, we will include the title you can see here. Next, we will add a card component to contain our audio samples. This card will help organize the content neatly. We will add a container with horizontal auto overflow. This setting allows our table to scroll if it becomes too wide. This table might contain a lot of content. We want to make sure it remains usable. Therefore, we will enable horizontal scrolling for it. Let's add the table to our structure. Inside this table, we will include a header row. The header will list our column titles. These titles are text sample, voice type, and audio output. Next, we will create the table body section. This part will contain all of our actual data rows. Next, we will loop through our natural speech samples array. This allows us to access each individual sample. Now we will add a table row for each sample. The key for each row will be the unique sample ID. We will add a table cell tag here. Inside this tag, we will include the text from our sample object. Let us check what we are getting in our browser now. Here, you can see the sample text displayed clearly. Next, we have the voice type column. This shows the specific voice style used for each sample. Next, we will add a button for playing the audio sample. This button will control the playback of the sound file. This play button will play the audio file from our sample. The audio URL is stored in our data array. If the audio is currently playing, we want to pause it. This allows the user to stop the playback. If the audio is currently paused, we want to resume playing it. Let's see how our play button looks in the application now. You can now see the play button appearing in this section. It is ready for you to click and test the audio samples. The multilingual section follows the exact same setup process. We will repeat the same steps we just completed. This creates a consistent structure for both sections. For the multilingual support section, I will use the same code structure. This approach saves us time and ensures consistency. Let us check what our application looks like now. You can now see the multilingual support section working perfectly. It functions exactly like the natural speech section we just built. The multilingual section follows the same pattern as the previous one. I will skip explaining that code again to save time. Let's move forward with the next part of our homepage. Now we are going to add this call to action button. It will redirect users to the dashboard page. Let's go ahead and add this button right here. This paragraph introduces a button with a call to action. The button text invites users to try the service for free. Clicking this button will redirect the user directly to the dashboard page. Let's check our application now to see this button in action. Now we will move on to the features section. This part will highlight the key capabilities of our application. Now let's add the features section to our homepage. We will place this section right after the audio demonstration component. Next, we will add a container element. This container will set a maximum width for the section. It ensures our content looks good on wider screens. Now let's add the main heading for this feature section. You can see the title clearly displayed in our application. Next, we will loop through all of our features array. Each feature will be displayed inside its own individual card. Each card will display its feature inside. You will find an icon, a title, and a description. Let's take a look at our application now. You can see all the feature cards displayed on the page. Now we are going to add the next section. This part highlights how our service is simple, fast, and professional. Next, we will create a new section for our application. We will add a section tag to contain this content. Inside this section, we will add a container element. This container will set a maximum width for our content. Now we can add the main title for this section. Next, we will create a container that has 3 separate columns. We will now add the 3 simple steps for our process. We are going to map through these 3 steps. For each item, we will display its title and a description. Looking at our application now, we can clearly see all 3 steps. Now, we will move on to the testimonial section. This is where we will showcase feedback from our users. Next, we will create the testimonial section. We start by adding a section tag. Then, we include a container to control the maximum width. Let's begin this section by adding the title at the very top. We will arrange these testimonials in a container that has 3 columns. We will now map through our testimonials array. Each individual testimonial will be displayed inside its own card component. We can observe the testimonial rating and content. We also display the name and role. If you check the application, our testimonial section is now visible. Now we are ready to build out our pricing section. This is where we will showcase the different plans for our application. Next, we will create the pricing section for our homepage. We start by adding a new section tag to the page. Inside this section, we will place a container. This container will control the maximum width of the content. Let's start by adding the title for this pricing section. You can see the title appearing in our application now. It has been successfully added to the section. We are going to add another container here. This container will set a maximum width for the content. We will use the large size setting for this. Next, we will create a pricing card for this section. Let's begin by adding the title for this section. The title will be Free to Start. We will now add the main content area for the pricing card. This content area will hold all the plan details. At the top of the card content, we will describe the free plan. This plan lets you try all features with free credits. Next, we will iterate through all the pricing plan features. We iterate through each feature in our array. We display every single feature item right here in this section. Let's check the browser to see our pricing section in action. The pricing card now displays all the included features clearly. Next, we will add a button to the pricing section. This button will redirect users to the dashboard page. It will have the text, "Try it for free." And finally, we're going to have a paragraph with this content. Includes 10 free credits, no credit card required. Our pricing section is now fully built and ready to go. You can see all the plan details clearly displayed. Now we are going to create the final section. This is our call to action area. Next, we will add the call to action section. We are going to use a section tag for this part. For this section, we will create a container with a div element. This div will set a maximum width for our call to action area. Next, we will add another container inside this section. This container will help us organize our content. This container will feature a title at the very top. Below the title, we will add a descriptive paragraph. Following these action items, we will add 2 important buttons. These buttons will be positioned right after that descriptive paragraph. The first button allows users to try the service for free. The second button lets them listen to some example audio outputs. You can see the result of our work here in the application. Now, we will build the footer section for our homepage. We will add a footer tag to define this area. Inside the footer, we will place a container to structure our content. We will then add another container inside the first one. Next, we will create a container with 4 equal columns. This layout will help organize our content neatly. We will place our application logo on the left side. This section displays our brand identity clearly. It features the sparkles icon alongside our company name. A brief description of our service is also included here. Next, we need to create a straightforward menu for this section. This menu will contain several navigation links. This section contains a simple menu. The menu includes links to features, pricing, and the dashboard. The menu items are now clearly visible on the page. We can see the links for features, pricing, and dashboard. On the right side, we will add one more menu section. This menu contains links for contacting support and managing account settings. The Contact and Account Settings menu is now visible on the right. We are now adding the final element to our page. This is the copyright notice at the very bottom. For the end of the footer, we will include a simple copyright notice. We have successfully built our complete home page with all the sections. Let's commit our homepage code to GitHub for version control and sharing. This ensures our work is safely stored and accessible to others. I am uploading all the voice files to my GitHub repository. This means you can download and use these audio samples directly. You will find them in the public audio folder within the project. Let's commit all our changes and push them to our GitHub repository. Our application will be deployed to Vercel in the next section. This process will make our project accessible on the internet for everyone. Let's begin by deploying our application to the Vercel platform. Let's start by opening our web browser. We'll go to Google and type in Vercel to find the website. Here is the website we need to access. It is called Vercel, and the address is vercel.com. What's even better is that Vercel is entirely free to use. You don't have to worry about any costs. Make sure you log in using your GitHub account. This gives you direct access to all your repositories. Look for the Add New button on your screen, click on it, and then select Project from the menu. You will now see a complete list of your GitHub repositories here. All of your projects are displayed and ready to be imported. You can see my project right here. It is the one I have been working on. The latest commit was just 1 minute ago. To proceed with the import, simply locate the Import button displayed on your screen. Click on it to begin the process. Our next step is to deploy the front end of our application. This is the user interface that visitors will interact with. Navigate to the root directory and select the front-end folder. Before deploying, you must add your environment variables in this section. You will need to go back to our .env file. Copy all the environment variables from that file. Paste them directly into this environmental variables section. We only need to change this Better Auth URL after the deployment. For now, we will keep it as localhost 3000. We can update this URL once the deployment finishes successfully. Let's go ahead and deploy our application now. The deployment process has now finished successfully. We can see that our application is live and ready to use. Let's head back to the dashboard now. Our deployment has been successful, and here is our domain. This is the web address where our application is now live. Let's click on this domain to open our application. Here is our deployed application running live on the web. Let's navigate to the sign-in page. We can try creating a new account here to test the functionality. Let's create a test account to demonstrate the sign-up process. Let's click the Sign Up button to create this test account. The sign-in process has completed successfully. We are now logged into our account. You can see the application is now live and fully functional. Let's navigate to the Create section of our application. This is where we can start making new content. Let's test the creation process by adding a new project item. Let's start by uploading a voice file first. The file upload has completed successfully and is working as expected. Let's create a new text sample for our project. We can then convert this text into a voice. Our new voice has been successfully created and added to the list. We can see the new voice entry right here on the screen. Let's navigate to the project section now. We can confirm the voice was successfully added there. You can see the credit has been successfully deducted. Let's navigate over to the dashboard now to see our project status. Our deployment appears to be working perfectly. All the features are functioning as expected. Now that your website is live and running, please copy the full URL from your browser's address bar. Navigate to your project dashboard on Vercel. Find and select the settings section. Inside the settings section, find the environment variables. Look for the variable named Better Auth URL. Update its value with the new domain you just copied. You can just click the edit button of the environmental variable. Replace the localhost URL with your new deployment domain. This ensures a more secure authentication process for user signups. That concludes the process of creating and deploying our project. We have successfully built a functional application from start to finish. I truly hope you enjoyed building this project together. Please share your thoughts about our final application as feedback. I am genuinely excited to see you in our next tutorial session.